and I will see you guys on the side. On the other side. There actually is some disgustingly good space news today that you guys probably will enjoy. All right, changing the title over on the YouTube side of things. Okay. Make sure you unmute the video. Okay. I'll be back in a little bit, guys.
When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the earth was flat, but around 350 BC, Aristotle proved that the earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the Earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion known as orbital mechanics. Today, orbital mechanics is applied to space flight and satellites that orbit the Earth or travel beyond our solar system. In the early 1600s, Johann Kepler, a German mathematician, using the data on planetary observations collected by the Danish scientist Tycho Brahe, developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits with the sun at one focus and the other focus empty.
Applied to Earth satellites, the center of the Earth becomes one focus, with the other focus empty. For circular orbits, the 2 foci coincide. Kepler's second law, the law of areas, states,
the line joining the planet to the sun sweeps over equal areas in equal time intervals.
When a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth. Speed is greatest at the point in the orbit closest to the Earth, called perigee, and is slowest at the point farthest from the Earth, called apogee. It is important to note that the orbit followed by a satellite is not dependent on its mass. A large, heavy satellite could be in the same orbit with a small, light one, each sweeping out equal areas in equal periods of time. Kepler's third law, the law of periods, relates the time required for a planet to make one complete trip around the sun to its mean distance from the sun.
For any planet, the square of its period of revolution is directly proportional to the cube of its mean distance from the sun.
Applied to Earth satellites, Kepler's third law explains that the farther a satellite is from the Earth, the longer it will take to complete an orbit, the greater the distance it will travel to complete an orbit, and the slower its average speed will be. Isaac Newton, the father of classical mechanics, laid the groundwork for orbital mechanics. He combined the work of Kepler and others to formulate the law of universal gravitation and the three Newtonian laws of motion. While Kepler's laws provided a conceptual model of orbital motion, Newton's laws provided the foundation for the mathematical description of orbits. They explain why a satellite stays in orbit. Newton's law of universal gravitation.
Any two objects in the universe, such as the Earth and the Moon, attract each other with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Stated more simply, the more massive the objects are, or the closer they are, the greater the gravitational pull between them. Newton's first law of motion.
A body in motion will keep moving at the same speed and in the same direction unless acted upon by an external force.
A satellite moves in a curved path around the Earth because the Earth's gravitational pull acts as an external force on it. Newton's second law of motion.
If the sum of the forces acting on an object is not zero, the object will have an acceleration proportional to the magnitude and in the direction of the net force.
Newton's second law states that force equals mass times acceleration. It is this mathematical equation and the equation for universal gravitation that forms the basis for calculating orbits. Newton's third law of motion explains how a satellite gets into orbit.
For every action, there is an equal and opposite reaction.
If you blow up a balloon and let it go, the balloon is pushed forward by the action of the air rushing out of it. A rocket's exhaust gases are like the air rushing out of the balloon. The following illustrates how a satellite stays in orbit. If a man stands on a mountain and fires a projectile horizontally, gravity will cause the path of the projectile to curve downward and it will strike the Earth. However, if the man fires the projectile fast enough at a specific speed, the curvature of its path due to gravity will match the curvature of the Earth under it. The projectile will then fall around the Earth, becoming an Earth-orbiting satellite. A projectile fired even faster will have a flight path away from the Earth, but gravity will act to slow the projectile down, change its flight path, and pull it back toward Earth. If the projectile's velocity increased enough, a velocity sufficient to escape the Earth's gravitational pull will be reached. This velocity is known as the escape velocity. It is equal to about 7 miles per second at the Earth's surface. The preceding description did not consider atmospheric drag and the Earth's rotation, both of which will affect the trajectory of the projectile. It illustrated the principles governing a satellite's orbit. There are 6 numbers called the orbital elements, which specify the size, shape, and orientation of an orbit in space, as well as the location of the spacecraft in the orbit. Based on an orbit which is an ellipse, the 6 orbital elements are length of the semi-major axis, eccentricity, inclination, right ascension of the ascending node, argument of perigee, time of perigee passage. The major axis of an elliptical orbit is the line joining the perigee and apogee. This line is also referred to as the line of apsides. The first orbital element is the semi-major axis. It is simply 1/2 the major axis. Circular orbits have no apogee or perigee. Therefore, the semi-major axis is simply 1/2 the diameter of the orbit. The semi-major axis is used to define the size of the orbit. From this, the orbital period, or time that it takes for the satellite to complete one orbit, can be calculated. The shape of an orbit is defined by the second orbital element called eccentricity. For all ellipses, the value of eccentricity lies between 0 and 1. The larger the value, the more elliptical the orbit. A spacecraft in Earth orbit with an eccentricity equal to or greater than 1 will escape the Earth's gravitational field. When orienting an orbit in space, a three-dimensional coordinate system must be defined. The coordinate system commonly used is the geocentric equatorial coordinate system, which has its origin at the Earth's center. This coordinate system is a non-rotating reference system in which a satellite's orbital plane tends to remain fixed relative to the stars while the Earth turns beneath it. The XY plane is the Earth's equatorial plane. The positive x-axis points to the vernal equinox. This is the point where the sun appears to cross the Earth's equator on its way north on the first day of spring each year. The z-axis is along the Earth's spin axis toward the North Pole. Nodes are points in a satellite's orbit which intersect the Earth's equatorial plane. The ascending node is the point at which the spacecraft crosses the equator going from south to north. The descending node is where the spacecraft crosses the equator going from north to south. The line joining the two nodes is called the line of nodes. The orientation of an orbit is determined by three orbital element angles. The right ascension of the ascending node is the angle between the x-axis and the ascending node. It is always measured eastward from the direction away from the vernal equinox in the Earth's equatorial plane. The argument of perigee is the angle between the ascending node and the point of perigee. It is measured in the orbital plane in the direction of spacecraft motion. Inclination is the angle between the equatorial plane and the orbital plane. A satellite which has an eastward velocity component at the ascending node has an orbital inclination lying between 0 and 90 degrees. Such an orbit is called a prograde orbit. A satellite which moves due north at the ascending node is in a polar orbit. Polar orbits have an orbital inclination of exactly 90 degrees. A satellite with a westward velocity component at the ascending node is in a retrograde orbit and has an orbital inclination between 90 and 180 degrees. The 5 orbital elements explained thus far describe the size, shape, and orientation of the orbit in space. The final element is a time value used to locate the satellite in its orbit. A satellite moves in a very predictable manner. It stays on schedule. Thus, if the time at which a satellite passes a particular point is known, the time when it will pass any other point can be determined. The particular point chosen is perigee, and the time of perigee passage is the last of the 6 orbital elements. The 6 orbital elements depict a spacecraft's orbit in non-rotating coordinates. To visualize an orbit relative to the rotating Earth, a projection traces the spacecraft's position on the Earth's surface. The projected path is called the ground track. As a satellite orbits the Earth, the ground track shifts westward. There are 2 causes for this. First, the primary contributor is the Earth's rotation toward the east under the orbital plane. Second, because the Earth is not a uniform sphere and bulges at the equator, its gravity is greatest at the equator. This causes the orbital plane to rotate slowly around the Earth's polar axis in a motion called precession. Precession is toward the west for prograde orbits and toward the east for retrograde orbits. For low Earth orbits such as those of the Space Shuttle at 150 miles altitude, the westward shift of the ground track due to the Earth's rotation is about 22.5 degrees, while the shift due to precession is only about 0.5 degree. The inclination of a satellite orbit determines the north and south latitude limits of its ground track. The minimum orbital inclination is equal to the latitude of the launch site and is achieved by launching due east. For example, if a satellite is launched due east out of the Kennedy Space Center, which is located at 28.5 degrees north latitude, its orbital inclination will be 28.5 degrees, and the limits of its ground track will vary between 28.5 degrees north latitude and 28.5 degrees south latitude. If launch azimuth or direction of flight at launch measured eastward from due north is increased from due east, the orbital inclination angle increases as well as the maximum latitude of the north-south ground track. Therefore, the latitude limits of the ground track equal the new launch inclination. Similarly, if launch azimuth is decreased from due east, orbital inclination once again increases as well as the latitude limits of the ground track. The maximum practical inclination from a Kennedy Space Center launch is 57 degrees. This limit is imposed for safety considerations in order to keep the spacecraft and its booster system from flying over land masses during the ascent phase. To obtain an orbit with an inclination greater than 57 degrees, the spacecraft is launched from Vandenberg Air Force Base in California. Vandenberg offers the opportunity for southerly launches with orbit inclinations between approximately 70 degrees prograde through 138 degrees retrograde. A significant advantage of launching from Vandenberg is the capability to economically achieve polar orbits with ground tracks covering all latitudes from the North Pole to the South Pole. The Earth is constantly turning, and all points on its surface have an eastward velocity, with the greatest velocity occurring at the equator. The farther the launch site is from the equator, or as launch azimuth is increased or decreased from due east, less of the Earth's rotational velocity will be imparted to the launch vehicle. This requires more fuel to get into orbit, or payload weight will have to be decreased. Launches due east from a position on or near the equator, such as the Kourou launch site in French Guiana, used by the European Space Agency, acquire the advantage of a free velocity gain of about 1,500 feet per second. This compares to the approximate 1,300 feet per second gain available at the further north latitude of the Kennedy Space Center. Launching from an equatorial site offers a significant advantage in payload weight capability and minimizes the amount of fuel needed to achieve an equatorial orbit. Since many satellites operate in equatorial orbits, these are important considerations. Spacecraft are launched within a specified time interval called the launch window. Some of the factors affecting the launch window are launch and orbit lighting conditions, sun angles, payload orbit requirements, rendezvous phasing if a rendezvous is planned, tracking and communication requirements, and collision avoidance with other orbiting objects, to name a few. One of the factors defining the launch window for the space shuttle is launch lighting conditions, which can be illustrated by plotting time versus day of year. On this plot, we see daylight and darkness at the launch site. The longer daylight hours occur in the middle of the year, summertime. If daylight conditions are required for a convenient emergency landing site for the space shuttle, the launch window would now look like this. During the winter months, the available launch window for lighting conditions alone can be as little as 3 hours per day. When combined with the many other launch factors, the launch window becomes even more constrained. The choice of a particular launch vehicle for a mission depends upon the weight and size of the payload and the desired orbit. Expendable rockets used to place spacecraft in orbit usually consist of several stages that may incorporate both solid and liquid propellants for propulsion. When the fuel in each stage is depleted, the spent stage is jettisoned. Staging offers the advantage of discarding weight when it is no longer needed. The space shuttle is a two-stage system. At liftoff, the 2 solid rocket boosters and 3 space shuttle main engines are all producing thrust. After approximately 2 minutes of flight, at an altitude of 25 miles, the fuel in the solid rocket boosters is depleted and they are jettisoned. The 3 main engines, fueled by liquid oxygen and liquid hydrogen carried in the external tank, continue to burn for several minutes until the shuttle reaches its cutoff velocity. At this time, the main engines are shut down and the external tank is jettisoned. 2 additional burns using the orbiter's maneuvering system referred to as ohms are required to place the orbiter in its final orbit. The ohms 1 burn occurs about 2 minutes after main engine shutdown and establishes the orbital apogee point. The ohms 2 burn takes place approximately 30 minutes later and circularizes the orbit. Once satellites are launched and put into orbit, it is often necessary to change the orbit with an on-orbit burn. The common term used in describing on-orbit burns or engine firings is delta V. Delta V is the incremental change in spacecraft velocity measured in feet per second resulting from the burn. The amount of fuel used during a burn depends on the desired delta V change and the mass of the spacecraft. Because the amount of fuel carried is limited, fuel consumption is one of the primary considerations in spacecraft mission planning and is critical to orbit lifetime. On orbit, a spacecraft can thrust in any direction. Burns along the flight path, forward and backward, are the most common. A unique feature of any orbital burn is that if no other burns occur, the spacecraft will later always pass again through the point of burn. Forward burns increase the spacecraft's velocity and are known as posigrade burns. With posigrade burns, the flight path of the vehicle will be raised at all points except the burn point. Burns opposite the direction of flight, which slow the spacecraft down, are called retrograde burns. For retrograde burns, the orbit will be lowered at all points except the burn point. The greater the delta V, the greater the difference between the pre-burn and post-burn orbits. Burns can be combined into maneuver sequences to change orbit size, shape, or orientation. One of the most common maneuver sequences is made up of 2 burns. and is used to accomplish an orbit transfer between two circular orbits in the same orbital plane. The most energy-efficient transfer between two orbits of this type is the Hohmann transfer. The Hohmann transfer is actually 1/2 of an elliptical orbit with its perigee in one of the orbits and its apogee in the other. The burns occur at the perigee and apogee of the transfer orbit. The use of the Hohmann transfer minimizes the delta V required, thus having the advantage of using minimum fuel. The disadvantage of the Hohmann transfer is that it takes longer than most other transfers. The type of the transfer sequence depends on the mission and the amount of fuel available. For example, a space rescue where time is critical might use a fast transfer, while a routine satellite deployment where fuel saved for later use is important would most likely use a Hohmann transfer. The burns discussed so far have all been maneuvers in the original orbital plane and do not affect orbit inclination or node position. There are situations which require an orbital plane change, such as setting up a rendezvous or placing a satellite in an equatorial orbit. To change the inclination, the thrust vector must be directed at an angle to the orbital plane. A thrust with a component that is perpendicular to the orbital plane at either the ascending or descending node will rotate the orbital plane about the line of nodes. A northerly out-of-plane thrust at the ascending node will increase the inclination of a prograde orbit, while a southerly thrust will decrease it. Out-of-plane thrusts require considerable amounts of fuel and are performed only when absolutely required. The Space Shuttle, for example, using all of its onboard propellant, is capable of an on-orbit plane change of less than 3 degrees. Satellite orbital planes and altitudes are determined by their design mission, which very often includes a field of view requirement for optical or communications purposes. The field of view of a satellite is defined as the area of the Earth's surface that is in view from the satellite at any given time. Satellites in high orbits have greater fields of view than those in lower orbits. For example, a satellite at an altitude of 800 nautical miles has a circular field of view with a diameter of about 4,100 nautical miles. A satellite at 200 nautical miles has a circular field of view with a diameter of about 2,000 nautical miles. Low-orbit satellites are often used for photography and other types of Earth observation. A satellite placed in a low-inclination circular orbit at an altitude of about 19,300 nautical miles will have an angular velocity exactly equal to that of the Earth's. The satellite would seem to remain stationary in longitude as viewed from the ground. Such orbits are called geosynchronous and are used to provide a continuous communications capability among any system of ground stations within their field of view. The geosynchronous orbit field of view is constant and is limited to a latitude zone of about 70 degrees north and south of the equator. Effective satellite communications from geosynchronous orbit is not possible at either pole. However, because of their altitude, their field of view covers nearly half the globe. A special type of geosynchronous orbit with an inclination of 0 degrees is called a geostationary orbit. It appears to hover over a fixed point on the Earth's surface at the equator. Most U.S. communication satellites are in geosynchronous orbits, providing near worldwide communications coverage. For effective communications at high latitudes, the Molniya orbit is used. Molniya is the Russian word for lightning and is an orbit used extensively by the Soviet Union for its communication satellites. The Molniya orbit is highly eccentric with an apogee that is near the geosynchronous altitude and an inclination of about 63 degrees. The satellite slows down at apogee in the northern hemisphere and whips through perigee in the southern hemisphere. This provides communications in the northern hemisphere for up to 75% of its orbital period. Several satellites properly spaced in Molniya orbits can provide constant communications at the northern latitudes.
Discovery, go at throttle up.
Navigation satellites, such as the U.S. Navy's Transit System and the Joint Service Navstar GPS Global Positioning System, use lower orbits so that a user can receive signals from more than one satellite at any time. Another frequently used orbit is known as a sun-synchronous orbit. These take advantage of the precession of the orbital plane caused by the Earth not being a perfect sphere. All sun-synchronous orbits are highly inclined retrograde orbits which precess eastward around the Earth's polar axis at the rate of 1 revolution per year. Since the Earth-Sun line also revolves eastward at the rate of 1 revolution per year, the orbital plane will maintain a constant orientation relative to the Earth-Sun line. If the satellite's period is then synchronized with the rotation of the Earth, it will pass over the same point on the Earth's surface at the same local time at a regular interval. A sun-synchronous satellite ensures that a constant sun angle and uniform lighting exist for the same field of view from pass to pass. Satellites such as those in the Defense Meteorological Satellite Program and Landsat are sun-synchronous, imaging the entire Earth on a regular schedule. The gravitational attraction of the Earth on a spacecraft causes it to move in its orbit around the Earth. There are other, much smaller forces which will cause a spacecraft to deviate from its desired orbit. These forces cause what are known as orbital perturbations. Orbital precession, which is used to obtain sun-synchronous orbits, results from the perturbing effects of the Earth's non-spherical shape. Other perturbing forces are the gravitational pull of the Sun, the Moon, and planets, and solar winds, which are charged streams of protons and electrons that heat the Earth's atmosphere and increase atmospheric drag. In most cases, perturbing forces can be compensated for in the spacecraft and orbit design and present no major problems. If the forces disturb the orbit too much, thrusters can be fired to re-establish its desired orbital orientation or altitude. This is particularly true for spacecraft orbiting at very low altitudes, where the effects of atmospheric drag are greater and, if not compensated for, will eventually cause the spacecraft to deorbit. A spacecraft's operational lifetime is frequently limited only by the amount of fuel available to maintain its desired orbit. When its useful life is complete, a satellite is left in orbit or is deorbited, burning up when re-entering the Earth's atmosphere. When the space shuttle completes its orbital mission, it executes a precise retrograde burn to initiate its controlled return to Earth. This burn occurs nearly halfway around the Earth from the landing site. The new orbit established by the retrograde burn causes the orbiter to enter the Earth's atmosphere about 4,000 miles from the landing site. During the period the orbiter descends from its orbital altitude to atmospheric re-entry, its attitude is maintained by the use of reaction control jets located in the nose and tail of the orbiter. Once the orbiter enters the Earth's atmosphere, its wing and tail aerosurfaces begin to become effective and gradually replace the jets for attitude control. As the orbiter nears the landing field, it maneuvers to a long, straight-in approach at an angle of 17 to 19 degrees. Nearing the runway, it executes a flare maneuver to reduce its sink rate and glides to a touchdown at approximately 230 miles per hour. As the orbiter rolls to a stop, our journey into the world of orbital mechanics comes to an end for now. This is only the basics of orbital mechanics, an intricate study of planetary and satellite motion. The next time you see a launch, you will see it from a different, somewhat knowledgeable perspective. You will understand the fundamentals of spaceflight.
Round of applause, round of applause. Round of applause. Guys, I have good news. Titan has pooped. A lot. We are all proud of him, and he is a good boy. That is all. Hey! Sit on the keyboard, man! This is the way. Thanks for the update. Oh, you're very welcome. He ran around, he got a drink, he got some food, he, went to the bathroom, and he's good to go now, but I didn't get anything to eat because I was busy cleaning that up. But anyway, I hope you enjoyed the orbital mechanics video, an intricate study of relative motion of conductors and fluxes. But it's time. Do you know what time it is? I wonder if we can still... Does this still work? It's time for space news. Why did it just change at the end there? Whatever. Okay. I'm Ron Burgundy. You stay classy, San Diego. All right. Let me start compiling the links here. There is some pretty good stuff. Pretty good, pretty poggies stuff in here, I'm not gonna lie to you. Let me get a couple of more links here. The FAA document review. Yes! Yes! We are gonna have to do that. Here. You know what we're starting with? You know what we're starting with? We're starting with this. What a shot. Oh. That's nice. Oh. If you haven't seen this, SpaceX released this footage. It was of the static fire, a Starship static fire the other day. And this is some hard rocket pornography right here. Oh, I can't stop staring at it. I'm staring at the trap, Ray. How did the camera survive? How do you think it survived? So Willie, let's think about it. You're gonna put a camera here. It's obviously extremely hot right now in this particular spot right here. How do you get a camera to survive? Think about it. How would you do it? So what would we do? Do we put a big lens on it? Big heat resistant lens? The camera is fire too. I mean, you could put a big lens on it, it's just going to smudge the lens. So how would you do it? Cameras like this are usually done through a periscope. So the camera is not near the pad. The camera is like down in the ground somewhere. Or knowing SpaceX, it's probably remote, right? And they just have a mirror and then another mirror, just like that. So 1, 2, 3, 4. You know what I mean? So the camera isn't near it. So you're just looking at a bunch of mirrors. Mirrors don't even worry about melting one of those, right? You could put it in a box. That way works too. It really depends on where it is in relation to the convecting heat that's going to come off these engines. I don't know if you guys noticed, there's an extreme vacuum going on here. Note the ice. Note which way the ice is going. This is ice that's falling off of Starship and getting sucked down into the flame trench. Flame trench. There's a huge vacuum going on here. So because there's low pressure, right, because of the vacuum, it gets really hot here really fast. I'll bet you this is a periscope. The reason why it gets really hot really fast is because, well, there's less air to heat up. Less air in the area is going to, if you introduce heat into low pressure, it's going to get extremely hot extremely fast because there's just less air to absorb the heat. It's funny because that's the name of your show on NSF. Speaking of that, I just confirmed my attendance for the Flame Trench this week. Oh. Big old meeting over there. Let me just make sure that the Flame Trench is confirmed. Okay. Anyway, cool. Yeah, we should be good for the Blame Branch. Oh, look, you can talk again. What happened? What'd you break? I don't think Jake will like that. Titan will unnerve him. Yeah, maybe. We'll see. Does it seem like Raptor Vac start up at way lower throttle versus the sea level? Looking at the mock diamonds, it's most likely due to the expansion ratio on the nozzle Katra. I knew someone was going to ask about that. This thing has a very clear mock disc, and you don't necessarily see that from the 3 sea level Raptors. Let me watch the ignition. It's most likely the shape of the nozzle that's doing that, but let me just check it. Let's take the slowed down video and slow it down even more. Okay, we got sequenced ignition. It's extremely close, but it is sequenced ignition. Watch. This one will go, and then that one, and then that one. Ready? 1, 2, 3. Actually, it was 1, 2, and 3, not 1, 2, and 3. That's a very, very close sequenced ignition. Okay, so right there, Yeah, so you could see some extreme flow separation happening there, but it should only be momentary. See that ring? See the ring that's in there? That's flow separation happening inside of the nozzle. We've seen this phenomenon before. The easy way to say what's going on here is that the explosion... So what does a rocket engine do? It creates explosions, and that explosion creates a lot of heat, and that heats up the combustion byproducts from the initial explosion, right? Right? So the explosion is not big enough, and it's not generating enough heat to fill up the nozzle. That's the right... It's not the exact way to say it, but the technical way of saying it would be that your flow rate isn't up to spec here. This happens during startup. This is a transient that kills rocket engines if you don't get it right. It's very important to get this right. But you are seeing some flow separation in there. And like I said, the easiest way to say, like, describe this in plain English is that the rocket engine isn't generating enough explosion and enough heat to have gases fill up the entire nozzle. So, watch. As the engine throttles up, you'll see the flow separation ring get to the edge of the nozzle. And when it gets to the edge of the nozzle, that's when a Mach disk will start. See? There it is. It's coming. That is an extremely violent thing going on there. So, Katra, if these engines were throttled down, like what you were saying, if these were throttled down, you'd have some insane flow separation going on here. But I'm not seeing it. That looks... I'll tell you when the engine's at full power. You can see that Mach disk starting to... It's trying to. It's a little turbulent, but it's trying. It's trying to form. There it is. Oh, dude, that's so freaking cool to see it all stabilize. That's when the motor gets up to not full throttle, but it's close. Oh, that is beautiful. Oh yeah, see how nice and stable and clear the plume gets right when the Mach disk starts to form. That's so cool. Oh, dude, come on now. That's a vacuum engine. You can make any nozzle work when you make 300 bar chamber pressure, crap. Like, let's be real. So we got 3 good engines there. And then they've started the startup sequence for the three sea level motors. You'll see the startup sequence will really kick in when these things start shooting out puffs of smoke. They're not puffs of smoke, it's atomized propellant. Atomized liquid fuel and oxidizer, atomized commodities if you really want to call it the right thing. Give it a second. Really a long chill down sequence there. There we go. Okay, all valves are open, pumps are on, and should get an ignition. There's initial start, and watch. It'll go Fusroda! Here, ready? Fusroda! There it is. Oh, that's so freaking cool. Note because of the nozzle, the different expansion ratio on the sea level nozzle, that the disc forms like almost exact, like straight up, right off the bat. But you could see, I mean, obviously there's a couple of different things going on here. Hey, Thrawn, what's going on? Commander EJ, the time has come. Execute Order 66. You could see that the higher expansion ratio is going to give this the nozzle at exit right here. It has a way bigger diameter, right? So you're going to get a bigger mock disc here. But the shape of the vacuum nozzle also has a lot to do with it. But it's mostly because of the bigger expansion ratio. It's a bigger nozzle, bigger mock disc. I was about to say mock disc, like mock disc. Oh boy. What temperature is it in the flame trench right now? Yes. That's beautiful. Oh. And you know you get to a nice good mixture right here when the plumes start getting super clear. Look at the sea level engines. You could see right up the nozzle, which is just magnificent. It is, guys, I'm going to go ahead and say that we're spoiled by that because, dude, getting methane to burn that freaking good is really, really impressive. It is that to get methane to burn that clean, because you got to think about it. We've seen other Methalox engines go, right? Blue flames, right? They have blue flames. That is clear. That is clear flames. Can you believe that? Unbelievable. To get methane to do that is pretty damn impressive. That's, I mean, testament to SpaceX's propulsion team. That's unreal. Dude, this stuff, this was not heard of 5 years ago. Well, COVID. 10 years ago, this was unheard of. Like, you can't do that. Last. Okay, what's on your mind, man? How much nozzle wobble does the vacuum Raptor get? Not a lot, because as T-Man pointed out, they have stiffener rings around them. They probably have the rings on them for that exact reason. Do you see the flow sep that's going on? Like, I mean, you did. You were here. See that flow separation right there? That can cause oscillations in the nozzle. That's why they have the rings on there. You can see, I'm not 100% sure if those rings fly. I'm pretty sure they don't. I make clear methane all the time. Did you just make a fop joke? Didn't notice the stiffeners. Yeah, no, that's a good question, dude. Great question, actually. Oh. That's just... Wow. I can't stop staring at it. That's just... Anyway. So, that was some SpaceX footage on Starship. I figured we'd start with that, but there is a lot more SpaceX news. There's a lot more Starship news, I should say. There's boatloads of it. So, before that, we'll get to Falcon 9 news. Falcon 9 did successfully return to flight. On early Saturday morning. That mission went off perfectly, and then just, to be absolutely sure that SpaceX wanted to be absolutely sure that Falcon 9 was working correctly, they launched 2 more. They launched 2 more, and those missions also went just fine. So 3 Falcon 9s have launched since the Flame Trench stream on Friday. They've had 3. Not boatloads, chip loads. Add that to the GIF roundup in the background. That's not a bad idea. Yeah. So they had 3 Falcon 9s teed up, and then when they got the green light from the FAA, they just sent all 3 of them, which is just damn impressive. Here, look, prompting SpaceX to tweet, "That's Falcon!" Anyway, whoa. missiles, but look at the photo. Okay, yeah, I'll check it in a second. I just... That's pretty good. Other launch companies. This is blasphemy. This is madness. SpaceX. SS Falcon. Are 300 memes still popular? That was like the thing to say when I was in college. Madness. The NSF cast on the return to flight said that there had not been a 15-day gap in Falcon 9 flights in over 2 years. Oh, geez. You're old. Thank you. No, you're old. No, you're old. No, you're old. No, you're old. Okay. 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 That's fine. Maybe I'll just keep my space news to Titan. Maybe I'll just tell Titan the space news now. Maybe I don't need to tell you guys anymore because you hurt my fifis. Titan, do you want to learn about stage combustion cycles? No? You sure? Full flow stage combustion cycle? No? What about expander cycles? Fuel rich stage combustion? Tap offs? Pintle injectors? Pintle injectors. Learn about the pintle injector, buddy. Learn about the pintle injector. Oh, doggo stretch. Doggo stretch. Want to learn about the pintle injector, pal? What about the full flow stage combustion? Linear arrow spikes? Toroidal arrow spikes, huh? Yeah. I didn't say you could have the ball. I didn't say that. I didn't say you could have the ball. Hey, sit. What? Sit. Okay. Guys, he didn't want to learn about it. All he wanted was ball. Which is fine. Not balls, not plural, ball. He just ball. Titan balls.
Discovery, go at throttle up.
G-Money, 40-month resub. Thank you. No rockets, only ball. Where's the ball? Where is it, Titan? Where's the ball? Where'd it go? Where is it? Where'd it go? Where's the ball?
Discovery, go at throttle up.
Where is it? Oh. Where's the ball? You want to get the ball? Go ahead, go get it. Go ahead. Where's the ball? He didn't like that. Booster rundown for the 3 flight. 1069.17, 1077.14, 1071.17. So I think I think SpaceX is back in business. That was good. That drought of rocket launches sucked. That wasn't fun at all. I actually heard this was in the NSF Discord as well. I heard that somebody was saying, I think it was Ryan or Alex, maybe Alex, it's probably Alex. In the time since the last Falcon 9 flight to the Falcon 9 flight right now, the return to flight. So Starlink, the Starlink got malfunctioned, and now there's been one rocket launch from another entity. 1. Yo, but like, where was the ball? I don't know. He's got it now, though. 1. Titan is exactly like the LR-87. Chill at some points and then very hyper. Yep. Yep. He bounces around like a missile. He can launch, dude. See, Kraken, this dog can jump. He can jump probably about 6 feet in the air. Like, when he jumps, his stomach is at my, like, head height. He's got some spring, dude. He is a spring doggo. Anyway, so, yeah, Falcon 9 back up and running. And, you know, as per usual, any flights that coincide with the streams, we will cover. And with that being said, let's actually look at what we have on the manifest for this week. We have SS-51, which is launching at stupid o'clock tomorrow morning. And we have Electron at 12:15, 1 for the Owl, 1 for Owl. Oh. Is that the last Atlas? No, there's plenty of them. There's at least 6 more, at the very least. I can think of 6 off the top of my head, the 6 Starliner missions. This is the final military launch. That's from Sandra Irwin over at Space News. It'll be the last national security launch for Atlas as ULA prepares to complete Vulcan certification for space missions. Interdasting. Planetary.
Discovery,
Cool.
go at throttle up.
Cool. Very neat. Insert clever space joke / pun here from Edmund Dantes for 14-month resub. Thank you. It shows how far behind the world would be in sat launches if it wasn't for SpaceX. Dude, yeah. Like I said, we've gotten spoiled by Falcon 9, and it showed that that 2-week drought kind of showed what it kind of gave you some perspective about what it was like back in the day. This is what it was like. 2014, 2013, 2012. This is what it was like. It wasn't fun. Just waited weeks before a freaking launch. Now you see them almost every day. And I ain't complaining. It's just, yeah, the drought, that sucks, man. But I think Falcon 9 pretty much has the record for shortest turnaround time after a catastrophic failure. Give me 1 second. Will Vulcan launch from Vandenberg? Yes, from Slick 3. Yep. Slick 3 East, I think. SpaceX mostly said on the NASA Crew 9 press conference what happened. Oh. Really? Let's see. Give me 1 second. It's a decent watch. All right, we'll go through it. The weather forecast for SF-51, 20% probability of violation, 15% POV. That's actually not too bad.
Rotational mission to the International Space Station. That is, of course, Crew 9. We do have leaders from both NASA and SpaceX today to discuss this upcoming mission.
Red Fox, did they talk about it in the initial thing, or did they talk about it after they answered when they answered questions?
We're going to start by providing some brief opening remarks, and then we'll open it up for questions both here in the room and on our phone bridge. So joining us today is Ken Bowersox, the Associate Administrator for NASA's Space Operations Mission Directorate, Steve Stitch, Manager of the Commercial Crew Program at NASA.
Too freaking real. Watch when they flip to that camera of the woman that's remote. She goes, "Oh crap, I'm out of frame," and she adjusts the camera.
So joining us today is Ken Bowersox, the Associate Administrator for NASA's Space Operations Mission Directorate.
Okay, I gotta change it and not
Steve
and
Stitch,
look normal.
Manager of the Commercial Crew Program at NASA.
Dude,
Dan
no,
Weigel,
it's too
Manager
real.
of the International
Oh, that
Space
happens
Station
on Flame
Program,
Trench all the
and
time.
Sarah Walker, Director of Dragon Mission Management for SpaceX.
See? She's like,
So
hey.
we'll first start with those initial remarks, and with that, I'll turn it over to Ken.
Hey, welcome everybody. It's great to be here today to talk about Crew 9, our next crewed mission to the International Space Station.
Kenny B.
I want to start by telling you how much I appreciate your interest in what we do. I think our work is exciting, but it's validating when I see how many of you have questions and interest in the work that we're doing.
All right, cool. Let's get to the questions. Here we go.
Fred, just regarding the
commercial custom.
potential.
All right.
There's actually some good in this.
Well, but from that process, it's
You know
formally
what?
defined by the
Manager
Maybe
of
we
the
should watch the
International
whole
Space
thing.
Station Program.
I'll start by telling you how much I in the
All
work
right.
that we're doing.
I'll skip through all the
If you look
gaps
at
and
Space
stuff.
Station
but-
right now, we've got
See.
5 different vehicles up there, 6 different ports with vehicles at their locations.
Can we boost
We
the
have
audio?
never
Yeah.
had
Of course.
so many vehicles and so many options. It complicates our lives, but in a really good way. But it causes us to work a lot harder as we balance.
Yeah, 5 vehicles. They have Progress, Soyuz, Starliner, Dragon, Cygnus, and Dream Chaser soon.
Need to do to get each vehicle up to station.
It's great.
And prepare it for its return home, and we do all the work that we have planned during the mission. There are so many different constraints, so many different activities that we're trying to squeeze in. It's really an amazing job of optimization that has to be done by our commercial crew program, our International Space Station program, our international partners, our commercial partners. I can't tell you how proud I am each day as I watch them work. And if you could be in the meetings with me, I think you'd be really proud to see them as they work to make sure we get the most out of every minute that we spend with our crews in space.
Real quick, fellas, when we watch press conferences, I tend to shut up. So if you see me kind of mouthing things, like, it's because I don't like doing exactly what I'm doing right now and pausing it.
Balancing risks, schedules, optimizing the work on the mission. That's the job that we do every day. And we'll do that job just the same with the Crew 9 mission. We'll launch when we're ready. We'll get them up there when the time is right. And we'll do our best to make sure that we return them to Earth safely. And now I want to pass the microphone over to Steve Stitch so he can give you some more details about the mission.
Yeah, thanks, Ken. Appreciate it, and appreciate the kind words. And thank you all for being here and for your interest in human spaceflight, and also your interest in our commercial crew program. We're excited to be here talking about Crew 9 today and talking about our next crew rotation mission. And the launch date right now is no earlier than the 18th of August off of pad 39A. We have a window that goes into the early September timeframe, and that's really driven by a pad turnaround for the Europa Clipper mission. We're off 39A, and that's a Falcon 9 Heavy as well off of 39A, so that's our window. We have a pretty busy timeframe. Ken talked about all the vehicles that we're flying to the International Space Station. So the overall sequence is to undock and bring Butch and Sunny home on Starliner, and then go launch the Crew 9 mission, and then do the direct handover and bring Crew 8 home. So that's our overall sequence of events in commercial crew. And as you know, it's a very busy time. It's been a busy summer for us. I do want to thank our entire team across the country who've worked so hard on not only Crew 9, but all of our missions over the summer. The NASA team has been doing a phenomenal job along with SpaceX and Boeing. You know, earlier this week, it's a big activity for the crew. The crew went down to the Kennedy Space Center and got into their Dragon spacecraft. They did what's called a crew interface checkout. It's an important activity to get the crew in their spacecraft to check it out, check out the suits and the seats in their interface. They did an ingress into the spacecraft, checked out all the displays, leak checks on the suit, and all the comm checkouts on the spacecraft. So that was a big activity that went very well earlier this week. You know, I talked to the crew earlier this week. I got to sit down with Zena and the crew, and they're very excited. They've completed all their training, and they feel like they're ready to go. And you'll hear from them this afternoon. So it's a great opportunity to hear what their excitement for the mission. And they're in good spirits and really waiting for the final phases of the hardware to get ready for flight. In terms of the Dragon status, and Sarah will give you a little bit more, but all the components for Dragon are at Dragonland at the Kennedy Space Center. You know, we have the nose cone installed, the heat shields installed, the trunk is ready to go, and so the next big activity really is to roll over and mate the trunk and the Dragon spacecraft together. That's really the most important activity, and we'll do this.
Real quick, he said rollover, so when they refurbish a Dragon capsule, because they refurbish them now, because it's a reusable spaceship. All right. Dragon is in an upright position when they do like the heat shield and the nose cone, and then when they go to put the trunk on, which it's the structural adapter for Dragon to Falcon 9. It also houses its radiators. It has fins for abort scenarios and solar panels. When they go to do that, they turn the capsule sideways and then attach the trunk sideways. So it's funny because they do that and then they take the whole thing and turn it upright again. Now, as to why, I have no freaking clue. I don't know why they do that way. Probably because it's easier to line up. Sometimes, you know, you're making this tall stack, right? Like, if you're going to stack, you need a tall building, and B, you need a lot of service gantries to do it. It might be easier to just turn the thing on its side, get it down near the ground, and attach the trunk to it, and then turn it back upright again. We do know the bracket that they use to deliver Dragon is definitely a bracket that it's L-shaped, and Dragon kind of sits on it like this, so it looks like it can pivot back and forth. But yeah, just a little bit of context to what Steve was saying there.
The center of gravity of the vehicle, and then get into, you know, some of the final checkouts of the prop system. On the launch vehicle, the first stage is at the Kennedy Space Center. It's going through its checkouts. We had to work through a little bit of a challenge with some moisture intrusion during transport from McGregor to the Kennedy Space Center, and the team's working through that, and that checkout's going well. Our second stage is at McGregor, Texas. It's going to undergo a second stage hot fire around the 30th of July, and that's really to check out some of the new modifications that vehicle will have as a result of the anomaly that Sarah's going to talk more about. We have been following along step by step with that investigation that the FAA has been doing. SpaceX has been very transparent. We've had our teams embedded in the investigation and following along all the changes on that booster. So that's been an important activity we've been doing. The crew will be flying aboard Dragon Freedom. That'll be its fourth flight. It flew on Crew 4, Axiom 2, and Axiom 3. And while we're here talking about Crew 9 today, I would like to announce that Crew 10 will be flying in February of 2025. That's the next flight, in order to give a little bit more time for Starliner to complete the mods after CFT. So Starliner 1 will move into the August slot next year, and we'll be double booking that slot with Crew 11. We're really excited to be here. It's excited to be
Starliner 1, Crew 11.
Working so many things in Commercial Crew. Have the honor of leading the best team at NASA, and it's an exciting time frame, and I'll turn it over to Dana.
All right, thank you very much, Steve. Thank you all for being here. Appreciate the interest that you have in this upcoming mission and also in the ISS mission as a whole. Let's see, as you know, Crew 9 will spend about 6 months on board. We've got 2 new flyers going up. We've got NASA astronaut Zena Cardman, and we've got Roscosmos cosmonaut Alexander Gorbanov. For Nick Hague, this will be his second flight with us. He did another expedition previously on board. Stephanie Wilson is flying for the fourth time, but this will be her first long duration mission. So really excited to have them on board soon. While they're on board, they'll spend a significant amount of their time conducting scientific research, got a wide range of experiments. Some of the highlights, some of the things they'll be doing, studying the behavior of intermittent or non-steady flame spread. We're interested in studying that because we don't have great ground models today that help us predict how wildfires spread. That's one of the big challenges we have. We're hoping to leverage what we can learn on board without the effects of gravity to improve our ability to predict what our wildfires here on Earth will do. The crew will spend some time studying cell changes, cell morphology, and gene expression changes for cells that have been exposed to long-duration spaceflight, hoping to increase our knowledge on the impacts to the human body when we do longer and longer missions. We'll also be looking at the physics of neutron stars, and the list goes on, but those are just a couple samples of the types of things that they'll be doing on board as they're conducting research. Of course, Butch and Sunny, have been on board. They're enjoying their time, and we're making great use of the extra helping hands. They've conducted a lot of extra research for us as well. Looking forward, we've got a busy time in front of us with vehicle traffic. We are working towards a Northrop Grumman Cygnus launch on August 3rd.
Cygnus.
That vehicle will berth on the 4th. After that, the week later, we've got a Roscosmos Progress cargo vehicle that's scheduled to launch on August 13th with a docking on the 15th. As Steve mentioned, hot on the heels of that flight, we've got the Crew 9 launch, a Crew Exchange, Crew 8 coming down. And then looking forward in September, we've got a Soyuz Crew Exchange. 72S is launching with NASA astronaut Don Pettit, and then 71S will come home, returning Tracy Dyson.
That's awesome.
After that, we've got a Dragon cargo mission, that's SpaceX 31, that we need to get up there. And then we've got a handful of spacewalks that we're still working to fit into this overall busy plan. If you recall, on June 24th, we ran into an issue with the spacewalk and had an early termination when we found a water leak in one of the umbilicals that feeds the suit. We've since addressed that. We've swapped out that leaky umbilical, and now we're just working to find time in the busy schedule.
Water leaks are no joke. If water starts leaking around in the suit, there's nothing stopping it from just floating around and finding an electronic to short out. That's a big deal. The other thing is that you can drown. Yeah, there's that. If it happened to an Italian astronaut when he was on EVA a number of years ago, Luca Parmentano. He had started at water accumulating in his helmet. And dude, you can easily drown if it fills up water and helmet. That's bad. That would be bad on the ground. That's really bad in a spacesuit. Yeah, and he was just like, there is water in my helmet. Control, can you check to see that there is water in the helmet? And then mission control is like, Roger, we are checking. That's exactly how that conversation went. How much water was there? Ever lasted? In reality, it's not like it was filling up. It was just a couple of drops. But dude, you don't roll the dice like that in space. That is a needless thing. Like you don't just be like, yeah, it's cool. That's one of those times where probably you'll be fine is probably not good enough. Mission control is powered by Ferrari. Ouch. Hey, man. Ferrari got on podium. Just saying. Ferrari got on podium because somebody's car was too light. Uh-oh. Whammy. Sorry about that. Whammy. Anyway.
To replan that series of EVAs. My expectation is that's out in the fall timeframe sometime. So we're still working through that. So as always, as Ken said, very, very busy on board ISS, very busy summer, and we've got a very busy fall, and we are really looking forward to having Crew 9 on board with us. And with that, I will pass it over to Sarah at SpaceX.
Yo, what up, Sarah? Hit us with the knowledge.
Hi, thanks for having me here today. SpaceX and NASA teams, as Dana and Steve have mentioned, have been busy preparing for the Crew 9 mission this coming up next month. Crew 9 will be our 4th Dragon mission this year. We previously launched AX-3, Crew 8, and Sirius 30, and it'll be our 45th Dragon mission to the space station.
What the frick?
You all know human spaceflight is core to SpaceX's ultimate mission to find...
Sarah, back it up.
I've been busy preparing for the Crew 9 mission this coming up next month. Crew 9 will be our 4th Dragon mission this year. We previously launched AX-3, Crew 8, and Sirius 30, and it'll be our 45th Dragon mission to the space station.
When did that happen, man? Yeah, I know Dragon 1, but when did that happen?
You all know human spaceflight is core to SpaceX's ultimate mission to flying crews safely, or to making humanitarian interplanetary, and flying crews safely is always our top priority. So on Monday, Steve was talking about what we call the crew equipment interface test. We like to refer to it as the Dragon test drive of the spacecraft because it is the first time that the crew gets to step into their flight vehicle rather than a simulator.
How many shuttle missions were there to the ISS? 35 assembly missions, dude. Stop that. No.
It's a good opportunity to do final suit-to-seat connection checks, audio, environmental controls, and more. But for me, it's a moment when it really sinks in that their journey to space is just around the corner because they're getting into their final flight vehicle.
Yeah, baby.
So as always, we will step through final launch preparations over the next few weeks. We'll fuel the spacecraft. We'll transport it to Hangar 39A. We'll mate it to the Falcon 9 and then roll it out to the pad ahead of dry dress activities, integrated static fire, and finally liftoff.
Discovery, go at throttle up.
So speaking of liftoff, the new Falcon booster that's supporting this mission is at the hangar, as Steve mentioned, and is nearing ready to fly. As many of you know, about 2 weeks ago during a Starlink mission, Falcon 9 first stage performed a nominal first burn, separated from the second stage, and returned for a successful landing. However, a liquid oxygen leak developed in the second stage engine. So the cause of the leak, I mentioned that this happened when I spoke with you guys last week, but I have a bit more detail to share with you today.
Yes.
And some good news. So the cause of the leak was later identified as a crack in a sense line for a pressure sensor. So this line cracked due to fatigue that's caused by engine vibration and looseness in the clamp that constrains that line.
Yeah.
We found it really interesting and positive that despite the leak, the second stage engine still continued to operate throughout the entire duration of that first burn where we observed the leak. It completed engine shutdown and then it entered a coast phase for about 30 minutes in the intended elliptical parking orbit. So the Starlink satellites are initially inserted with the second stage into an elliptical orbit with a low perigee and a high apogee. And then after about 30 minutes, we perform a second burn to circularize at the higher altitude. So unfortunately, the fluid leak that we saw in the first burn in the cold of space led to excessive cooling of the engine components, and most importantly, those associated with delivery of the ignition fluid to the engine. So when it was time to restart the engine for the second burn, it experienced a hard start because there was slow delivery of that ignition fluid to the chamber. That damaged the engine hardware, and then it caused the upper stage to lose steering capability. So these are things that we think about in the design and build of these vehicles. So the second stage itself continued to operate as intended in a scenario like this. So what it did is it proceeded to deploy the Starlink satellites and then successfully passivate itself. That's a process where it vents down stored energy in the stage, which that occurs at the conclusion of every Falcon mission. So in other words, the stage sensed that there was something wrong with the engine. It went ahead and did its payload deploy sequence and then passivated itself to safe it for deorbit. So For the near-term Falcon launches, we actually just removed this sense line and this sensor from the second stage engine. It's not related to the flight safety system in any way. It's not used for that system, so we're able to just remove it. It's redundant with alternate sensors we already have present on the engine, but that location tends to see a bit more vibration. So we can get the same data from our other sensors. We just pulled that line out of the engine for the near term. And that design change has actually already been tested at our rocket development facility in McGregor, Texas. So,
she did, Jen.
Steve also mentioned that our teams have been performing this comprehensive review with the FAA as part of the formal investigation process, but also of all of our SpaceX vehicles and our ground systems, including Dragon. So we wanted to ensure we've been meticulous and thorough with what we've learned as we return to flight. And I have good news to report, which is that yesterday the FAA formally approved us to return to flight.
This was on Friday.
They agree with the conclusions of our investigation and the corrective actions taken, which is really good news. We actually expect Falcon 9 to return to flight this evening, launching from Launch Complex 39A.
So this part was, this meeting was on Friday, so just bear with me. So yeah, that sensor, the clamp on the sensor was already in a high stress area. But what did I tell you guys? It was a sensor. It was a pressure line sensor on the starter plumbing. She said, she didn't say mission fluid. She said ignition fluid. It's the pyrophoric ignition. It's triethyl aluminum and triethyl borane. So it was the starter. I call it. That's what I said. Like, I'm not trying to toot my own horn, but that's what I said based off of what we saw from that mission. We watched that whole thing many times. So did it go bang or burn up? It passivated itself and then deorbited with the reaction control systems. From what I understand, from what she just said, yeah, it safed itself just fine. Somebody tightened down a bolt too hard. Somebody overclamped that line, and it caused it to fatigue. And it was already a high stress line, and it bent. So they just said, screw it, we don't need this. Just take it off. And that's what they did. Pretty straightforward stuff. That's actually super cool. That's what I mean. Like, I knew that this, because there'd been, just because of the sheer volume of Falcon 9 flights, there was something before this. It was like 340 missions and change with Falcon 9. This was somebody tightened something down too hard. Somebody over torqued something. It's something very, 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 very minute. And it turned out to be just a little sensor. And the clamp that holds that sensor to the line, just somebody tightened it and it cracked it. That happens. That stuff happens, dude. It happens. I mean, you'd be damn sure SpaceX won't make that mistake again, right? But yeah. So someone gave it 3 Ugga-Duggas when they should have given it 2. That's what it sounds like. She said that there was fatigue on a sensor component because of the clamp. Because of the clamping mechanism caused a crack. She didn't say they over tightened it, but that sounds like somebody tightened a bolt down too hard. Think someone got fired? It really depends, dude. If this was an idiotic thing, why? I mean, let's be real. It was enough for them to take the sensor off, so I don't think anybody would have gotten canned from this. It's something that they knew about and something that they said they needed to be checked, so they probably just said, screw it, we don't need the sensor anymore. I don't think someone would get canned over this, guys. That's not like, oh my God, you're fired, you screwed up. You know what I mean? This is just like, a guy's going to tighten something down and somebody's like, hey, come over here. And he's like, all right, give me his, okay. It's something stupid like that. Trust me on this one. But they won't say that, right? They don't want to say, oh yeah, we forgot to tighten down a bolt. You know what I mean? What if Elon was having a really bad day? I don't know. Can't speak for him, dude. Anyway, I'm going to let Sarah talk again.
How quickly the team was able to identify the cause of the mishap and then associated corrective actions to ensure success of future missions. So shifting gears, I know when I was with you last week, you were asking about this topic of trunk reentry or trunk demisability. So shifting gears, I'd like to share some exciting updates we have planned for Dragon there too to address those recent findings. So after 5 years of splashing down off the coast of Florida, we've decided to shift Dragon recovery operations back to the West Coast.
Yep.
So that's where we recovered the Dragon cargo spacecraft 21 times between the years of 2011 and 2020. And we will be sharing more detail associated with this on our updates page later today, but I wanted to provide you some insight ahead of that since we are here together. So when we were developing Dragon's current reentry operations, which we've used for all our crew missions and then cargo missions since CRS-21, SpaceX and NASA engineering teams use these industry standard models to understand the trunk's breakup characteristics. And they predicted the trunk would fully burn up due to the high temperatures that are created by air resistance during that high-speed reentry into Earth's atmosphere. They should leave no debris. And that was a determining factor in our decision to passively deorbit the trunk and enable Dragon splashdowns off the coast of Florida. So today, Dragon's trunk is jettisoned prior to the vehicle deorbit burn while still in orbit. That leaves it in space while the capsule comes down and does a pinpoint splashdown, and then it passively re-enters and breaks up in the Earth's atmosphere in the days to months that follow. Because the trunk doesn't have any maneuvering capabilities of its own after separation, the location and the precise timing of that trunk reentry can't be predicted. It's dependent on solar activity and atmospheric conditions and a number of other things. So to date, of the new Dragon trunk and operational concept that we've been flying since I think 2019 or 2020, to date, the majority of that trunk debris has reentered over unpopulated ocean areas. But the fact that any debris has reentered indicates to us that we need to draw a different conclusion from that initial analysis. And so I just want to say that we are committed to safe spaceflight operations and to public safety. It's at the core of what we do. So after we first discovered this, I believe it was back in 2022 when a piece of trunk debris was found in Australia. We quickly worked to make some immediate changes that could be implemented quickly to improve our probability. But then we also launched into a big effort to work with NASA and the FAA to pursue a longer term solution. And that's where we are today with this move back to the West Coast. So what we'll do is we'll implement a software change to complete the deorbit burn before jettisoning the trunk, like we did with Dragon 1. And then the trunk will intentionally land safely uprange in an unpopulated area of the ocean again. So to make this change possible, we'll move a Dragon recovery vessel to the Pacific sometime next year. And we'll use SpaceX facilities in the Port of Long Beach for our initial post-flight processing. Then Dragon will be transported back to Florida for preparations for its next launch. So I do want to say this isn't just going back to the old way of doing things, especially considering our human spaceflight recoveries have never before been executed from the West Coast. So instead, I see it more as taking a familiar operations concept and applying it to the Dragon we fly today, finding a way to combine the public safety benefits of West Coast recovery with all the benefits of crew transportation services and enhanced cargo return capabilities that we provided the last 5 years out of Florida. So continued innovation of spacecraft design and operations, this is critical to ensure Dragon continues to safely fly to and from Earth orbit. This new path, I believe, will make it possible while also keeping the public safe as we work towards becoming a spacefaring civilization. So again, I encourage you to keep an eye on our updates page for even more information. I think it will be posted later today. I do want to note, since this is a Crew 9 mission briefing, that the Crew 9 mission will still splash down off the coast of Florida as our teams are working to fully transition this entire operation over to the West Coast. And we hope for that to be complete shortly after Crew 9's return. So all of these updates, the rapidly solving the root cause of the stage 2 issue a couple weeks ago, finding safe solutions for Dragon trunk recovery in response to new information, I really think they're all a testament to the relentless, creative, hardworking, agile, vigilant teams here at SpaceX that I'm proud to call colleagues and friends. So on behalf of that team, I can say that all of SpaceX is excited and ready to launch Crew 9 safely to the International Space Station and support all of the incredible science and research they'll conduct throughout their mission. Thanks for including me today, and thanks so much to Dana, Steve, Roscosmos, NASA, everyone for your trust and your partnership. I'll see you in a couple weeks for launch.
Thank you to our briefers for those initial remarks.
Dude, that was about as comprehensive as you can get right there. Sarah covered a lot of information real fast, dudes. That was a lot of info. Wonder if the ISS battery lawsuit played a part in the calculation. Misadventures, I don't think so. No. She talked about the trunk coming down in Australia. That was not the only place that a trunk came down in one piece. Well, it's not coming down in one piece. It's specifically the flange that connects the trunk to Dragon, if I'm remembering right. It looks to be a big aluminum piece, and it's sandwiched in the carbon fiber. And that piece, just for whatever reason, comes down. And when it comes down, it just the way the trunk flows through the air, it comes down in a shard. Hang on. It comes down in a shard and it like embeds itself into the ground. Here's the piece right here. One came down in Australia. Another one came down in the Pacific Northwest. Another one came down in Canada. Here's the piece. This is the piece that, as far as I can tell, keeps surviving. I think the guy in Canada took it and he wanted to sell it he wanted to sell it back to SpaceX to make money for his town or something. But yeah, this is that's the piece right there. It's definitely a piece of the trunk, and that's that aluminum plate that I was telling you guys about. And that see that kind of dowel pin right there, or that kind of cup right there, that's where Dragon links to the trunk. So like Dragon, the heat shield would be right here, and then Falcon 9 would be over here. But yeah, this piece pretty routinely makes it through every time. And you can't roll the dice with uncontrolled debris re-entering. That's not a good idea at all. Yeah, that happened, dude. That was the one that came down in Canada. There was another one in Australia, the same piece. That did a Planet of the Apes, same piece. See what I'm talking? Actually, that's not the same piece. That's a fin. That's one of Dragon's fins. So there are clearly a lot of components that are making it through. Explain like I'm 5. Why can't they include a breakup mechanism for it? What does a breakup mechanism for the trunk look like? I don't mean to answer your question with a question, but that's the reality of it. What does that look like? So we're adding an additional detonation mechanism. Long story short, you're complicating things. And what do you want? Something that breaks up the trunk into a bunch of small components? Reentry already does that. That clearly doesn't solve the problem. That's what I mean. Like, say we had some type of explosive mechanism on it. So you're adding mass to the spacecraft, makes it less efficient. You're adding more rocket on your rocket, right? We don't want that. You're adding complexity to it, right? And arguably you're not improving anything. Because once again, this thing burns up, and clearly components can flux enough heat to be able to make it through. So blowing it up into a bajillion pieces is probably not going to change anything. If these components will still come through. So the best, I kind of agree with SpaceX. Like, no, you kind of agree with the rocket company, EJ? Oh, crap, damn. The best thing to do is to just re-enter and have it land out in the Pacific. Now, I'm not going to sit here, have the trunk just land out there. Now, I'm not going to sit here and say, like, if, that thing over there on the far left monitor up there, that thing didn't need to worry about that. See that thing right there? That thing doesn't need to worry about that. It just, just lands on a runway. That's kind of cool. Just saying. Yeah, I'm shamelessly plugging the shuttle. 13 years on, I don't care. Still gonna do it. When they land over the Pacific, because there's the approach that they take to the Pacific Snarkletooth, it gives you a much wider area that's unpopulated. Here, let me show you what I mean. Oop. Tell that to the Australians in the external tank. What? What are you talking about? So, here. If they're going to recover, and say your recovery point is like right here near the Channel Islands, right? And ISS is 51 degrees inclined, so that makes your track... That makes the... Actually, the orbital trajectory would be over here. Something like this. See what I'm talking about? Actually, the ISS orbit is a little more tilted than that. It's down here somewhere. Something like this. See, that scenario basically opens up an extremely wide corridor where it's very unlikely that it'll come over a populated area, right? In the time of the deorbit. Most of it, at least half of it, is over water. So that means the trunk is most likely going to come down in the ocean somewhere over here. That gives you a much wider window because, as Sarah said, it can't be predicted. That's really hard to get that right, to the point where you're never going to get it right. That's like, that would be like, and please, for the love of God, never do this. That's like taking a gun and shooting a bullet like straight up in the air and predicting accurately where that's going to come down. Absolutely not. No way. There's weather up in space, right? That's a thing. That's absolutely a thing. Space meteorology, it's called orbital perturbations. If you watch the orbital mechanics video that I had during the break, that happens. Solar winds can blow this thing around its trajectory. Then there's just regular wind when it comes down. Is the trunk tumbling? Is it tumbling front to back? Is it doing a Magnus effect and you know, like spinning sideways? Is it listing lazily to the left? The trunk might know some maneuvers. You don't know how it's going to come down because it's uncontrolled. It's a ballistic reentry. That's really hard to be accurate with. That's why the US and the Soviet Union spent billions of dollars trying to get that more accurate over the course of 70 years. Well, maybe not 70, but you get the idea. Yeah, Eagle, Skylab landed on Australia, I think, dude. I don't think an external tank ever made it to the Australian coast. But either way, yeah, that's cool. That's cool. That's some good information there. Here, I don't know if you guys want to hear the press questions from this conference. I bet you one will be about the SpaceX Red Fox. You already said that. I bet you another one will be about Starliner. I'd like to point out that this is a Crew 9 Dragon press conference. Somebody will ask, well, what if Starliner doesn't get out of the way? Watch. Ready?
A couple here in the room if we have them before jumping over to our phone bridge. If you are on our phone bridge, please press *1 to submit your question. If you find your question has been asked already, you can press *2 and you can withdraw it. Once your name is called, please do state your name, affiliation, and to whom you'd like to direct your question. And if at all possible, try and keep it to one question so we can get through as many as possible today. I'll start here in the room.
Oh, thank you, Mark Corot with Aviation Week and Space Technology. My question has to do with the Falcon 9 second stage before you launch the Crew 9 mission with astronauts. What will NASA do to certify or make sure that the issue that arose a couple weeks ago has been dealt with in a way that meets your safety standards? Thank you.
Yeah, thanks for the question, Mark. We've been following along all the way through the investigation, so we agree with everything that Sarah talked about.
Yeah, you ain't wrong, man.
We understand the root cause. The root cause was really the sense line that she talked about that was potentially a little under-designed, I would say, for that environment. So
Actually,
what we're going to do on Oz, the root
back it up.
we've been following along all the way through the investigation, so we agree with everything that Sarah talked about. We understand the root cause. The root cause was really the sense line that she talked about that was potentially a little under-designed, I would say, for that environment. So what we're going to do on our stage is exactly what Sarah talked about. We will cap that sense line, and we'll remove that pressure transducer that's measuring the liquid oxygen pressure in the pump. And we'll go through a rigorous certification of that. So we're going to look at all the changes to the flight software that now won't utilize that sensor. We're looking at all the hardware changes associated with that. We understand exactly what they've done relative to that change. And so we'll go through that and take it to the program control board, and we'll baseline that change for Crew 9. The beauty of what they've done is we'll get, hopefully we'll get the Starlink mission that Sarah talked about off this weekend, and we'll probably get another couple flights in there before ours. SpaceX has made this same change on a very similar second stage to ours that's already been through testing at McGregor. We followed that testing, and we'll follow the same testing on our stage. So we'll get a check of that sensor in this second stage test, like I spoke on the 30th. So it's our process for dealing with changes, and we'll work through all the data, work through all the analysis and certification, and then we'll be ready to go fly.
Yeah, baby.
Thanks, Steve. We'll do another question here in the room. Go ahead.
Hi, yes, Will Robinson Smith with Spaceflight Now. Appreciate y'all taking the time to talk to us. Question, I believe, for Steve and Sarah, if she'd like to join in. You mentioned the timing of Crew 9 needing to happen within a certain pocket to transition over to the Falcon Heavy configuration for Clipper. I wonder, is there still some outstanding work or validation that needs to happen with the crew tower over at Pad 40? And just wondering why that wasn't used as the primary for Crew 9 so that there wasn't a potential conflict. Thanks.
Yeah, good question. We've been working really hard on the certification for Pad 40, and we're close. We've tested the crew escape system. We've tested all the pad systems, but we're not quite complete on certification. If we were, we would entertain moving over to Pad 40. So that's probably a little bit more like late September timeframe. So we just sort of missed this window together with all the work that NASA and SpaceX had on our plate. We just didn't quite get there. So that's why we're going to fly off 39A.
Okay. Another question here in the I think Sarah wanted to jump in, if that's okay. Then we'll go to you, Gina. Thanks.
Yeah, I'll just chime in really quickly that, I agree with everything Steve said. So the Pad 40, the build itself, the preparation of the pad is complete. You may remember we launched CRS-30 off of that mission, but then there's a joint certification effort specifically for human spaceflight missions that we do in partnership with Steve's team. And we've been working through that process to make sure all the T's are crossed, all the I's are dotted before we would fly a CCP mission off of Pad 40. I think we could have done it by this mission. We're nearing completion, and huge thanks to Steve's team for all the hard work there. But we have several weeks of runway on 39A. The Clipper mission is in October. It does take us a little bit longer to convert the pad to the heavy configuration, but I wouldn't say that we're running out of time or that there's not enough room to launch Crew 9 when it needs to be launched. And then I wanted to go back to a previous question really quickly. Perhaps maybe some helpful context is that the issue that we observed on the Starlink mission two weeks ago actually wouldn't have occurred if this were a Dragon mission, because the first stage and the first burn of the second stage actually completed the mission exactly as intended. It was something unique about the mission profile of that mission where we coast for a long time. It's very cold in space, and that small leak, while it didn't affect the burn, did make the components where that liquid was present get really cold. And so we never assumed that an issue is isolated, while that issue would not have occurred had that been a Dragon mission, because there is not a second burn or that coast period. We still use that to launch into an audit of every system on that vehicle and every other vehicle. So we did do that scrub, but I thought it might be helpful context that this issue was a little different than what we would see on the mission profile of a Dragon mission.
Thanks, Sarah and Steve. Okay, Gina, go ahead.
Gina Sinceri, ABC News for Dana. For the cargo mission, the Cygnus flight that's going up, tell me about the critical cargo that's going up. We're kind of missing that briefing. It's the same time as this, right? And are any of Butch and Sonny's belongings that they had to take off for the pump going to make it to them before they come home?
Yeah, great questions. As you know, on every single flight we fly, we've got a lot of critical things. There are basics on board, food and water. We have that almost every flight. Crew supplies, research. In terms of some of the unique things that we're flying, we have a couple what I'd call critical ORUs. You know, we tend to on board spare the vehicle with one spare critical component for each item. And so when you have a failure of that, you got to resupply it. So the couple things that just stand out off the top of my head, I do have another one of the urine pumps that we had talked about previously that we had problems with. In fact, the one on orbit's acting up a little bit. The one we had to quickly fly on Starliner was a more immature design, a shorter term unit. This is our longer term legacy, very robust unit that I've got flying up on NG-21. We've got a couple other things, like I've got some navigation sensor replacement, hardware, a docking reflector replacement, a couple things I need for some of the other EVAs that we had originally planned to do in the fall. In terms of items for Butch and Sunny, we did go ahead and put, since we took their suitcases off their previous flight, I had some things loaded here early on. We had to make manifest decisions very early, and not knowing when things would line up, we did put some things on there which can also be used generically to backfill the generic supplies. So there are a few things, not a lot of really super crew unique items, but a couple things to help backfill.
Thanks, Dana. All right, we'll head over to our phone bridge. We have Bill Harwood with CBS News.
Hi, thanks for doing this.
Thank you very much. A real quick one for Sarah. Are you saying that the FAA has cleared SpaceX to launch, period? Or is there anything outstanding you guys have to do in regards to licensing before Crew 9 can fly? And I'm sorry, I got to ask the second one for Steve. You mentioned how you follow along in lockstep with SpaceX when there's a failure investigation like this. Can you give us a little more detail on exactly how you do that? Is there any hands-on work that NASA or its contractors do to verify what SpaceX is saying? I mean, I'm not challenging that. I'm just saying, or is it just you guys just reviewing the data that they present you to conclude that everything's okay? I'm just trying to understand better what depth of oversight NASA has into recovery from an anomaly like this. Thanks.
Sure, I'll speak for a minute. So so there is a standard licensing process for every launch where we have to submit licenses and be approved. And so that's still ongoing like every mission. But specific to the issue that we saw, yes, the FAA has given us their final determination, which means in all of the daily briefings and digging through the data that we did together with the FAA, and that's actually something that NASA officially has a seat at the table to participate in all of that. We stepped that process. It's formally defined by the FAA when stuff like this happens, and we stepped through that process. We submitted our data. We had a Q&A period where we exchanged more data, and then they've given us the final determination yesterday that they agree with our conclusions, and we are ready to return to flight. So I know Steve mentioned that they will also have a board meeting to gather their teams and review that data, communicate, and make sure that all the NASA teams are ready to fly as well. But from the FAA perspective, we're ready to return to flight.
And I'll take the second part of the question. In any investigation, NASA can do additional analysis, additional tests. It really depends on the nature of what happened, the nature of the anomaly, how much additional testing we will do. I would say in this case, what we did was we participated in the development of the fault tree. We reviewed all the telemetry that SpaceX went through to determine the root cause, the video analysis that they did to determine the root cause. We went through all that with them. All the testing that they had planned to do to show that this was the potential cause of it. In fact, SpaceX actually went back and looked at some, the stage that flew on the Starlink flight. There was actually some signature maybe in a test at McGregor that could indicate that there was a potential problem there. We sat down and reviewed all that data with SpaceX. So this one was more of a working side by side with SpaceX and looking through everything that they did and all their corrective actions. I would say SpaceX went above and beyond the specific cause of this particular sense line issue. They went and looked across the Dragon vehicle. Are there anything like this on Dragon? Also on the first stage of Falcon 9, is there any other P-clamp or sensor that's just like this? So we really followed along and looked at all the data. In this case, because SpaceX did such an extraordinary...
Hold up. I'm going to pause Steve for a second. They lost a P-clamp. Oh, someone tightened down a P-clamp too hard. Okay. All right. Now I know what people are saying. What the frick is a P-clamp? I have one in the garage. I'll be right back. I'll get it for you. Stay there. I'll be right back. Hey, I'm back. It's okay, buddy. I'm back. Not talking to you, Chad. All right. So, this is a P-clamp. That's it. It's that simple. This is used for hard lines. So if you had like a sensor on this and you tightened it, right? If this was clamping a sensor, you could break it very easily. So how does this work? There's two tabs. See the two holes? So you'd put like a brake line. I have them because you put brake lines. You use them to mount brake lines, which are very similar. Brake lines on a car are very similar to the pneumatic lines that are on rockets. Very similar. It's just designed to hold a steel pipe. Pneumatic, hydraulic, whatever. Now brake line is hydraulic, right? But here, take a look. Right there. That's it. It's just a little sucker. Just like that. I bet you it's about this big. Something this freaking big can cause an entire mission to fail. That's rockets, dude. Yeah, the dog is like, is that food? But yeah, that's a P-clamp. You know, they call it a P-clamp because if you look at it from the side, it looks like a P. See? You have the two holes, you'd throw a bolt through there. It holds a line in place. Is this 3/8 OD? I think this is a 5/16 P-clamp, Willie. Now, I don't know if SpaceX is using 3/8, 5/16. It looks like, it's probably not in standard. B, yeah, it might be a little bit bigger than this. This was clamping a pressure transducer. So I'm going to go ahead and guess it's probably bigger. If I had to guess, it's probably 13 mil. Where am I pulling that out? A half inch. Because, yeah, that's 13 mil. It could be 10. I mean, I don't know. It could be anything. It really depends. So the P-clamp turned into a no-clamp. No, the P-clamp worked from what I can tell. It looks like someone over-torqued that and crunched the pressure transducer. That's what happened. I was telling you guys, when we watched that Starlink mission fail, whatever that was is a pinhole leak. It's very small. And there you go. That's a P-clamp, dude. That's cool that Steve said that because now we learned something. See? It's just a little guy. This is a small one. There's a probably bigger. Or they used the wrong size clamp. There you go. That's an easy mistake to make, dude. It could be a B or a D. Where's my boy? Hey, buddy. So what was sitting on the first stage camera? Now that I don't know, Katra. That I don't know. It also doesn't explain what came... No, I've heard no explanations here as to what came off that first stage at T plus 10 seconds. Something came off the first stage. Or something came off the launch vehicle, right? Did Titan have a good WALK? Yes, he did. Yes, he did. Optimus wouldn't make that mistake. Anyway. I'm going to back that up just so we can hear it one more time.
Their sense line issue, they went and looked across the Dragon vehicle. Are there anything like this on Dragon? Also on the first stage of Falcon 9, is there any other P-clamp or sensor that's just like this? So we really followed along and looked at all the data. In this case, because SpaceX did such an extraordinary job, we did not go do any additional testing or analysis. We didn't feel like that was required. So.
Was there a mission that failed recently? Yeah, Goldrix. Falcon 9 mission launched 2 weeks ago, and there was on the second stage engine. First stage went fine. On the second stage, when they went to start it, they developed a liquid oxygen leak. You could tell because it looked like a winter wonderland out there. The engine was still running, right? But, which, once again, I called that. Like, the mainline plumbing on the motor was fine. Somebody tightened one of these, a P-clamp around a sensor. Could have used the wrong size, could have over-tightened something, and it cracked the line because of the fatigue, because the rocket engine's vibrating around. So if this thing, even though it has a rubber isolator, is the wrong size or it's over-tightened or something, right, and the rocket engine is weeble-wobbling around, it could break a line, and that's exactly what happened. It broke a pressure line that had to do with the ignition fluid mechanism on the second stage. Yes, I said ignition fluid. No, that's not like blinker fluid. Falcon 9's engines, first and second stage, use what's called a pyrophoric igniter. They use triethyl aluminum and triethyl borane. Those are two fluids. When they chemically combine, if they find oxygen, it becomes hypergolic with oxygen, basically. That's the right way to say that. If you take T-Tab and you mix them, if it finds oxygen, it'll explode. That's what they use to spin start the turbine machinery, which is driving your fuel pumps on your rocket engines on Falcon 9. If there is a pressure transducer on that line and the pyrophoric ignition ignites, that pressure transducer was to detect O2 levels, so that tells me, once again, it's either going to the transducer somewhere on the way to the T-Tab cartridges, or it could be after it. I don't know. I don't know the specifics of the motor. But, yeah, it cracked. It cracked the line. I'm telling you guys, little guy, something this big. Can you believe that? That's why it was so cool that Steve Stitch just said it was a P-clamp or a transducer, because that tells me, based off of what Sarah said, that somebody P-clamped a transducer. Now, I'll be honest with you guys. I'll be 100% real. I don't know dick about rocket engines. I'll be honest with you. I know nothing. I know nothing about the technical aspects of this. And when I say technical aspects, I mean how you put it together. I can build cars, not spaceships. However, P-clamping a transducer seems like a no-no to me. I will say, unless, once again, in spaceflight could be different. You usually use this to clamp hard line, not sensors. You usually don't clamp sensors at all, because they're usually delicate. Wasn't T-Tab used for the SR-71 start? Yes, that's right, Nader. Yes, absolutely. The J-58, yeah, had pyrophoric ignition, because when the SR-71, when it decided to go Mach chicken, right, they'd shut the J-58 off. They'd shut the turbojet off. And then when it went back down and started to slow down, they needed to turn that sucker on again. They used the same thing. They sprayed T-Tab into the intake, and that caused an explosion that basically pressurized your compressor and turned the combustors back on. Yep. Yeah, absolutely. That's where they got the idea. The SR-71, as far as I can remember, was the first one to do it. Yeah, it was going Mach chicken. I mean, is it not, Dama? It's going pretty fast, right? Don't throw T-Tab in the harbor. No, you just throw T in the harbor, okay? T-Tab belongs in rocket engines. Mach butthole? Off topic. In KSP, does higher flow priority drain first or last? Higher priority first. It's always the 50-cent part. Yeah, Hellfish, I'll be honest with you. P-clamping a transducer a pressure transducer doesn't sound right to me. But then again, well, what do I know, dude? I play Kerbal. I have no freaking clue, you know? If you ain't first, you're last. If you ain't first, you're last, all right? What the heck are you talking about, Nubius? You could come second. You could come third. You could come fourth. Heck, you could even come fifth. That wouldn't be something you have the freedom to decide where to put it. The P-clamp was on a sensor line, and its failure allowed unrestrained vibration and caused a crack. I assume, yeah, that's a better, yeah, you're right. They're not P-clamping the sensor itself. That's just the, yeah, that's a good point. Yeah, I know you don't decide. There's a hole in when it was made. You put that in the hole, and you do not drill a new one, right? Any idea what tech they're trying to hide with all this UAP stuff? Just fancy drones? XNB, if I had to guess, it's hypersonic stuff. Hypersonic stuff. That's the new game changer, because hypersonics can... Okay. Little bit of a detour into military doctrine here. I'm an armchair general. I don't know, but here's the thing. I do know about rockets and how they work and via airplanes and stuff, right? So here's the thing. All right. The UAP stuff that we don't know if they're trying to cover up. They've said they just don't know what it is. It's compartmentalization, obviously, right? Like, we don't know what it is. But if I had to guess, it's a hypersonic drone. So why is this a big deal? So in the past, you have an ICBM, intercontinental ballistic missile. So what does that mean? You have a rocket that goes up, just like it's delivering payload to space, except it stops just short of circularization, right? And then it lets go. And then you have your payload is ballistic, meaning it's unguided, right? It just kind of sails off and it's like lobbing an artillery shell, right? That thing comes down. It comes down, goes through the atmosphere so ridiculously fast, you're never going to hit it with anything. Now, here's the thing. Nuclear trajectories they're very, it's easy to predict it. You're just not shooting it down. So that's why the only thing to do is to launch ours. We can't shoot theirs down. They can't shoot ours down. We're under nuclear threat. Launch it. Send it. Because you do have like 15... 20 minutes before it comes down, so you know, right? And then you launch in that 15, 20 minutes, and at best, you've mutually blown up everything. So that's mutually assured destruction, right? Hypersonic missiles, right? Especially like a hypersonic nuclear missile, can not bypass it, but you won't know where it's coming from. You'll be able to see it, but the hypersonic missile, you won't be able to predict its trajectory. It'll change course. It can change course. They could basically steer at re-entry speeds. That's not anything new. The space shuttle did that. That thing's been doing that since the 70s or 80s, early 80s. Pick your poison, right? So my guess is that they have hypersonic re-entry vehicles that don't really re-enter. They launch on a missile and they can steer around it, so you don't know where it's going. An ICBM, you know where that's coming down. Everyone that has nukes has an early warning system. You'll be able to see it coming. You cannot see where the hypersonic missile is going. That missile really knows where it is. Let me put it to you like that. So, yeah, I don't know if that's the response you were looking for, XNV. I don't know if that was a troll question or not, but yeah, it's probably hypersonic stuff. That's like the new hotness in defense spending, dude. Tozer, it's hypersonics all day. Hypersonics is the hotness, dude. That is the new hotness right now. So hot right now. Hypersonics, so hot. The hypersonic shotgun needs development because it knows where it isn't. Yeah, exactly. You also won't be able to see until it comes over the horizon. Exactly. You know, when you launch a nuke, it goes up into space. Anybody with an upward-facing radar that's worth its weight in scrap metal will be able to see it coming. The hypersonic missile comparatively stays really low to the ground. You will not see it until it's at your doorstep. That's a good point. That sounds more believable than anything I heard. Yeah, Tozer. What do you think? It's aliens? I mean, it might be, but I think that's a lot more plausible. Nobody, during the Cold War, nobody wanted to know that we had the DoD didn't want anybody to know we had an SR-71. And every time someone saw one, it's like, oh, it's aliens. No, it's an SR-71. Does the SR-71 look like a plane from the 50s? No, absolutely not. But the reason why they didn't tell anybody about it until the 90s, was because they didn't want to, you don't want to show your hand with defense doctrine like that. You do not want to show, you don't want to show your hand. You just want to put the chips on the table. It's a freaking poker game. It was the SR-71 and aliens. Was the SR-71 on the radio at Tal going, Algarada? What's up, man? Do you have that tweet from Boeing about Top Gun Maverick that came out? Yeah, dude, I remember that. I don't have it, but I remember that. But yeah, hopefully that makes sense, dude. CIA had their own SR-71s. That's right. Is that the plane that's outside the Space Museum near the Coliseum in LA? That is an A-12 Nubius, but yes. So there are different variants of the SR-71. The SR-71 was that was an Air Force variant of the Blackbird platform, I guess. There were many different versions. There was actually, I can show you. So the SR-71, which is the Air Force variant, was derived from the Lockheed A-12. Like, if you looked at an SR-71 and A-12, at face value, they look exactly the same. That's an A-12. That's an SR-71. Now, that doesn't mean that there was only the A-12 and an SR-71. They did make a bunch of these things. There were a bunch of different variants here. Where's all the different variants? Yeah, see, so I'll just go down the list. So there's the A-12, there was the YF-12, which the YF-12 was an interceptor version of the A-12. The A-12 is the fastest. The A-12 was operated by the CIA, by the way. Yeah. The YF-12 was an interceptor version that the Air Force looked into. Basically an SR-71 that goes up, shoots a missile at an incoming bomber, and then comes back down. And no, you're not, yeah. Whatever that thing gets near and shoots at is basically dead. That never ended up doing that because it was too expensive. And then there was the SR-71. There's the SR-71A and the SR-71B. Like once again, you look at all these planes, Nubius, they look exactly the same. Like, you will not be able to tell the difference. Except for the YF-12. The YF-12 is the one that looks a little bit different. The YF-12 has this kind of cut nose. Some people love it, some people hate it. I actually think it looks kind of cool. But the reason why they had the cut nose is for sight, so the pilot can see. Because SR-71s are hard to see out of. The radar sight, excuse me. Radar, not like actual sight, like looking out the, I mean, it is kind of looking out the window, but radar, not like visual sight. I misspoke. Sorry about that. Sorry. Yes, you're right. Yeah, they put that big old radar in there. I knew it was one sight. I forgot it was the radar sight, not the actual visual sight. Excuse me. But yeah, see, it has that cut right there. And then there's one with a bunch of different variants. Long story short, yeah, there was a couple of different ones. But yeah, I don't know what you'd call all of them. You know, I would say like Blackbird. The Blackbird family of planes, but that doesn't, I know that's not right. No one calls it that. There's also evidence the SR-72 is being flown by Skunk Works and is nearing production. Expect a Mach 6 to 7 operationally manned with recon and conventional nuclear payload delivery repost. I'll bet you it deploys a hypersonic missile, Nader. Now, see, and here you go. Once again, if you have something like that can go Mach 6, right? And you can deploy a hypersonic missile, hypersonic nuclear missile at Mach 6, and then have that accelerate all well in the atmosphere, that's first strike. That's what's called first strike capability, right? Now, you know, those hypersonic drones make a lot more sense. You would not want to tell anyone about that. Just zip it. Shut the hell up. Don't talk about it, right? Am I right? Wasn't there also a trainer with another cockpit? Yes, there's a couple of different trainers. Yeah, of course. The interceptor variant was designed to punt the missile out the back because the aircraft flew faster than the missiles could fly. Yeah. Agalex, I started thinking about that a second ago when I was looking at this. I was like, wait, AIM 47s? Wait a minute. wait a minute. Right? That makes a lot more sense. Definitely wouldn't want people knowing about that. Anyway, there's your defense doctrine bit of the day for space news. NASA got their hands on them too. NASA has had a hypersonic glider re-entry vehicle for a long time now, for about 50 years. That thing. The space shuttle. Seriously. What do you think that is? It's a hypersonic re-entry vehicle. It's not ballistic, but then again, neither is a hypersonic missile. The first rule of first strike is you don't talk about first strike. That's also the second rule.
All right, our next question on the phone bridge is from Jeff Faust with Space News.
All right, back to space. Jeff?
Dragon manifest. I know before the Falcon 9 anomaly, you were tracking a launch of the Polaris Dawn Crew Dragon mission around the end of this month. Where does that fall in the manifest now, and is that a potential candidate for launching from Pad 40 while 39A is in the Falcon Heavy configuration?
That's a good question. Yeah, there you go.
That's a question for you, Sarah, but I can answer if you would like. We still have Sarah?
Oh, sorry. Can you hear me now?
Yes.
Okay, great. Yes, we are in final preparations for Polaris Dawn. We are so excited about that mission. We're still holding a late summer slot, and I think this is just kind of evidence of the great partnership across all of our NASA missions and all of our commercial customers to ensure that we fly each mission when the time is right. And so there's a lot going on ISS right now. We opted to fly the Crew 9 mission as our next mission, and are ready to fly Polaris Dawn late summer as soon as we fulfill those obligations.
Word.
Thank you. All right, next up is Micah Maidenberg with the Wall Street Journal.
Oh, Misadventures, you were talking about SR-71s. Yeah. NASA did have SR-71s. Yeah, they got a couple of them when they retired them. Just like they retired the F-117. Just going to leave you with that one.
Hey, good afternoon. Sarah, just regarding the second stage anomaly, the recent one, presumably the sense line worked in the past and many times. So again, could you just help me understand why this issue came up with this particular flight? I know the company statement mentioned engine vibration and looseness in a clamp. What caused that? Was that something on the ground at SpaceX, or was there something different with kind of the ascent and operations for that Starlink mission? Thanks a lot.
Yeah, I'll say that the only unique thing compared to the other flights is this location actually had two connections instead of one, which was driven by actually a customer requirement on another mission, not a NASA mission, and we left it in that configuration for this flight. So yeah, we are looking into that. But I think there's a little nuances about how this line is attached. It's in a location that is a bit more susceptible to vibration as this rocket gimbals and fires. So a small crack developed in this case, and then a small leak of liquid oxygen. This is an area where from the main chamber, some liquid oxygen is allowed to come through the line so that the sensor can then measure pressure. And so that little bit of oxygen that came through formed a small crack. A bit came out, and then that in the cold of space over about 30 minutes made that line so cold and a couple lines around it that we weren't able to deliver the other fluids as quickly as we needed to start up that engine for the second burn.
And I'd like to add a couple things. I mean, I think this is great evidence, and what I told our team of you think about the big things on a rocket. You think of the big gimbals that move an engine. You think about the turbo pump. Think about the flight computer and things like that. But this sort of shows the attention to detail that's required in space flight. Essentially, SpaceX made a small change to a different transducer. There was an in-house transducer pressure measurement for this particular sense line attached to the sense line, probably not knowing exactly how sensitive this area was to vibration, and how the insulation was attached and how this clamp was attached. And then they removed the clamp, and so they did analysis on that, and it looked good. But the combination of those factors, the kind of material that was used, removing the clamp was important, and kind of even the way the tubing was made was important. So what I've found and what SpaceX has found here is it was a small change that you would think would be innocuous, but that I think is a good lesson learned for all of us in human spaceflight.
Yep.
And in spaceflight in general is small changes matter, and we had looked at the change and we didn't see any problem on the NASA side as well. So SpaceX has done a great job of going back and looking at this area and then any other areas on the vehicle that could have a similar problem, where you did a qualification by a little bit of similarity to what you had before, but maybe without having quite the thorough testing that you should have.
Yeah.
And so I think that was a great lesson learned for all of us.
Yep.
Next up, we have Jackie Waddles with CNN.
Now I'm wondering what that requirement was. Fish, it would take someone with deep pockets to change the requirements for SpaceX for a mission to have them make a change to propulsion. Red Fox, they don't ask that. We know who it is. We can use some logical extrapolation here and figure this out. Okay, who has deep pockets? That's a SpaceX customer. NASA and the DoD are the biggest ones by a long shot. By a long shot. SpaceX has NSSL. They have the NSSL contract. They have the 40% share of national security missions. Meaning they're launching all. Since the NSSL contract was awarded a number of years ago, they have 40% of all Department of Defense planned missions until 2028. So, the DoD is a big customer. So is NASA. She didn't say it was a NASA requirement. So, what other missions are out there that would require them to change around their propulsion, particularly in the restart department for their second stage? It's those missions, those Falcon Heavy missions where the second stage has a gray stripe on it. Because those are the missions that require the most amount of engine restarts. Those direct to geo missions, or those geostationary transfer missions. So, yeah, you need to have deep pockets to get SpaceX to change their propulsion systems around. Because the reason why is exactly what Steve Stitch just said. You do not change stuff without testing. Do not change. Probably doesn't cut it. Probably never cuts it. That's a really bad idea. We don't do probably here. Right? I know I keep saying that, and it's like you're a broken record. It's like you're a broken record. It's like you're a broken record. It's like you're a broken record or something. But it's true. You don't change stuff without testing. And then in this case, they did, and they thought, it won't be a big deal. And then it was a big deal. Done. There you go. Willie, is that the LA speed check video for SR-71? That's a good video. I know about that video. So this is really smart. Bonks, hey, all right, I already fixed the spinning, man. Damn. Didn't you hit me? Man, it's going to leave a mark. All right, cool. Red Fox, thank you for recommending watching this. I'm actually learning a ton here. I love NASA press conferences. You learn so much, even with the seemingly stupid questions. But actually, this press conference has had some pretty damn good questions.
And thanks for doing this. A quick follow-up question for Sarah. So I just want to make sure I understand, too. How do we know for certain that a problem like this couldn't arise on the first burn? I know you mentioned this wouldn't affect a Dragon mission for that reason.
I jinxed myself. I said there were all good questions. Sorry. That's my bad.
It was only the specific flight profile. But was there any steps you took to ensure that a leak like that couldn't cause a fuel issue earlier in the flight? And then also just really quick, if you don't mind, could you kind of lay out SpaceX's overall Falcon 9 flight profile ahead? Just wondering where Polaris Dawn might land on the schedule now. Thanks so much.
Hey, yes, so your first question was about are we sure that this is isolated to the specific line and the specific sensor? That's exactly what that root cause process, Steve described the fault tree. That's exactly what we do. That's what the FAA investigation is intended to do is you start with a list of every possible cause that could have caused this to happen, and you slowly drill down using flight data and telemetry to eliminate or exonerate. No, this isn't a possibility because of this. This one's not a possibility because of that, until you get down to the most probable cause. Or in very clear cases, we were really lucky this time to have a ton of data. The stage we were talking to it and receiving data throughout this entire time, all the way through passivation. And so we had a lot of flight data to work from to see really really clearly the timing of everything and the locations of everything. And so, yes, we do not just consider the issue that happened to be an isolated issue, but use that to then kick off corrective actions for that system and look into every other system that might have the same vulnerability. I think maybe one other thing I wanted to go back and address from the previous question about configuration. I think this is maybe an example of why SpaceX really feels strongly about testing like you fly, and then also flying regularly so that we get a lot of flight heritage and history on our hardware and know how it works in every situation. So sometimes we need to fly a really unique mission for a customer that drives a necessary configuration change to the system. But the number of times we're launching in a year, we want to take credit and have the data from every one of those previous launches to inform the next one. And so that's why we hold as tightly as we can to making every vehicle the same, so that it's the same body of data and we know how it flies because we've done it a lot before. So I thought that was an important thing to mention as well.
Thanks, Sarah. Next up is Joey Roulette with Reuters.
Thanks, Sandra. First, Steve, I just wanted to follow up on your remarks about Starliner. Is having the astronauts, Butch and Sunny, return to Earth in Starliner required for Starliner certification?
Thanks, Sarah. Next up is Joey Roulette with Reuters.
Thanks, Sandra. First, Steve, I just wanted to follow up on your remarks about Starliner. Is having the astronauts, Butch and Sunny, return to Earth in Starliner required for Starliner certification?
No, it's not. No, it's good. Joey, come on, man. Oh my God. All right. Let's hear what Steve says. He's probably going to be not as much of a dick as I am.
Question relative to Starliner. We would like to return, as I've said, our prime option on the crewed flight test is to return Butch and Sunny on Starliner. We would like to get all that data for certification. The importance of returning them on Starliner really is to look at the suit-seat interface, how the crew interacts with the vehicle during the deorbit burn and entry, and then the recovery operations as well. We've recovered cargo from the two uncrewed flights that we've had. Now it's a little different with crew, right? You have a crew on board, and the ECLSS system has to work a little harder during entry with those crew loads.
ECLSS is environmental control and life support systems. Yeah, it's under load because there's people inside and people have to breathe, just in case you were wondering. You're welcome.
And then, at recovery, demonstrating that whole end-to-end process of getting the crew out of the vehicle, how the landing and recovery team interacts with the vehicle, and then, that is important for us for certification.
So is that required, or is that something you guys just want?
Were you listening, bro? He just said that. look at Steve Stitch's face. Just look at his face. No, Joey Roulette he's all over the place, dude. He writes some pretty good articles, to be honest. I don't understand this question.
It's something we would desire to have. We would have to talk about, if we didn't have it, would that be, meet all the certification requirements, so.
Our next question is from Stephen Clark with Ars Technica.
I hate this.
Hi, thank you. I think my questions are probably for Sarah. Just to clarify from your statement about shifting Dragon recovery ops to the West Coast, is it your intention to shift all, you mentioned moving one recovery ship, so will all Dragons be splashing down off the West Coast, or will you still have Florida as, or the Gulf or the Atlantic as an option? And just refresh my memory on the reasons for initially splashing down off of Florida, and what do you give up in terms of turnaround time or I guess doing the deorbit burn with the trunk? You presumably need to consume more propellant, so what do you give up in terms of performance by making this change to the West Coast? Thanks.
I will tell you this right now. Jettisoning the trunk and then doing the deorbit burn does have a little bit to do with Delta V, but it's absolutely about making sure your trunk is separated. What if you do your deorbit burn and the trunk doesn't separate? You're screwed. Completely screwed. They tried re-entering once during Mercury with the retro pack installed on the back because it didn't separate. Didn't end well. Yep. That happened. Oops. Here, let's see if Sarah says the same thing.
Sure. Yeah, thanks for your question. So yes, we do want to move all Dragons to the West Coast. There may be a small transition period as we're moving vessels through the Panama Canal over from East Coast to West Coast, where we can support either coast.
Yes, Bill.
Our kind of FAA trajectory deliverables will all include past and present sites. And so we similarly did that with Dragon 1, I believe. Let's see, we moved we flew the Demo 1 mission, a crew mission, out of Florida in, I believe, 2019 before our last cargo mission on the West Coast in 2020. And so we may see a similar transition period as we're moving all of the hardware and facilities and infrastructure. But yes, we will eventually land all Dragons on the West Coast. We have launch pads on both coasts, and we also have Falcon recovery operations. And so those, by nature of the flight profile, will remain on both coasts. The booster will land on the coast where it launched. So we'll still have recovery operations in Florida, but all of Dragon will be on the West Coast. And then I loved your question about what do you give up? Because you're right, when we were developing our new concept of operations, NASA gave us new requirements, starting with CRS 21, for even tighter return timelines, enhanced science capability, and that was all factored in when we were designing and building the whole system in Florida. And so that's the new challenge ahead of us now, and what we've been working through here this year is how do we come back to the West Coast but still maintain all of what we've learned and stood up to support crews, not just cargo, in terms of quick return to handover for NASA, support of possible contingency situations,
Yep.
And how do we keep even faster cargo handover timelines than we did for Dragon 1. And so, yes, we're working through all the details of that, but it will be a better capability than we had back in Dragon 1 by design. And that's the problem space that we're solving right now, is how to do that here on the West Coast when we had initially designed it all in Florida.
Our next question is from Elizabeth Howell with Space Doc.
That was a good question. Stephen Clark usually asks a good question. That was good. Spaceflight Now is good, people. Yeah, there's still launching crew out of Florida. Sarah was just saying, they set up Dragon all in Florida. It's not just like the recovery vessels and stuff. The refurbishment facility called Dragonland, Steve referenced it a little bit earlier in this press conference. That's all their Dragon refurbishment is there. Like, that's it. The Dragon capsules are built in Hawthorne. Well, were. I mean, they might be building a couple more. We don't really know. But all the refurb stuff happens at the Cape, just like the shuttles. The shuttles were built in California, and then they were refurbed at the Cape. Except if there was like a crazy big thing that needed to be refurbished on the shuttles, then in which case they'd fly them back to California, right? Yeah, that sounds like what Sarah said. Awesome, dude. Yeah, yep. Mm-hmm. Yeah, they built one more crewed Dragon. There's a fifth. Yeah, so SpaceX has 4 operational capsules. Endeavor, Resilience, Endurance, and I forget what the last one is, to be honest. I don't remember. This has all happened so ridiculously fast. I don't remember the last one. But they are building another one, yeah. Can somebody Google it? Somebody Google it. Incontinence. Nice. All right, I'll do it. I'll do it. I'll do it. I'll do it. So there's endeavor, resilience, endurance, and freedom. That was the last one. That's a great name. Oh yeah, freedom. It's a great name. Yeah, C213 under construction. Final Crew Dragon to be built. Construction is planned to finish in 2024. Yep. Yep. Just realized the clickety-clack of your keyboard is gone and I kind of miss it. Oh. Okay. How many cargoes do they have? $205. I didn't know they well, yeah. 204 bit the bullet. That sucks. $203 was the EC for the ECLIS testing module, still in use for human in the loop testing. That's it. Get a noisy keyboard. Endeavor, resilience, endurance, and freedom. And then they have 1, 2, 3. 3 uncrewed. 208, 209, and 211. Oh, damn. This is so cool. Dude, it's so cool to see pods get used like this. I kind of wish, like, the shuttle had a resume like this in the short amount of time, but that's fantastic. Yeah, active dock to the ISS. That's so freaking cool. Anyway, let's finish up this press conference. Hopefully there's good questions coming.
.com.
Thanks, everybody, for taking the time. This is for Dana. And so until the suitcases get up there for our CFT astronauts, how are you working on resourcing them, especially for things like clothing or food or any other consumables that you were thinking were going to be more like a 10-day mission and less like a 50 or 90-day mission? Thanks.
Yeah, there are any number of challenges that we can face that result in a shortage of supplies on board. For example, if you have a cargo flight that slips out. And so the way we deal with those risks generically in the program is we keep what we call a contingency reserve on board. In general, that's about a 4-month supply.
Kind of explore.
That applies to things like food, water, oxygen, nitrogen. And so we keep a buffer, and we do that for crew supplies too, things like clothing. And so we had plenty of generic supplies on board, so we just had Butch and Sonny use those. And as I mentioned before, we'll replenish some of those generic supplies on NG-21 and then also on the upcoming SpaceX 31 Dragon cargo flight. But we keep that reserve level high enough so that we can deal with any number of different contingencies or uncertainties.
Thanks, Dana. Next up, we have Jonathan Suri with Fox News.
Thanks so much for doing this, everyone. My question is for Dana. Is the Crew 9 launch contingent at all on the return of Starliner, or would ISS...
Okay. I don't want to watch this press conference anymore. I don't want to watch this planet anymore. The Lank made it up there. Yeah, Alamander and 2 B-29s with it. Doc and Fifi and one of 2 Lanks, man. That's really cool. Can we get a new timeline, please? Fellas, I'm skipping that question, okay?
Interested in it. This question is from Jim Siegel with Florida Media Now.
Hi, everybody, and thanks for taking my question. I'm particularly interested in activities related to growing food in the ISS and beyond in longer-term flights. Are there any such experiments, new experiments planned that are going to go up either on Crew 9 or on the Cygnus flight? Thank you.
I'd have to look at the specific manifest, and I can get back to you on that, but I will just make kind of a generic comment that we've got a couple of different facilities that we use. We've got one called Veggie, and we've got an advanced plant habitat, and we tend to keep those pretty busy. The cycles for growing and how long it actually takes to grow out seeds, sometimes we have to adjust and flex, but those are often pretty highly occupied facilities. During harvest time, it gets pretty exciting for the crew on board. In the past, we've had tomatoes, we've had chili peppers, and the crew always wants to eat them, and so we have to share some of them with the scientists and some of them with the crew. And so those are always really exciting opportunities. But we'll get back to you and see what we have on the manifest and what's around the corner for plant growth.
Okay. I'm sorry, I'm just catching up with both chats. Respect for this shuttle in the video you showed. Break was so interesting. Yeah, dude, it's awesome. Yeah, Red Fox, that's funny. She gets super candid. That's hilarious. Today's local newspaper has a story about how Butch and Sonny are still stuck on the ISS. Oh yeah, that's it. So Tozer, I wanted to reply to what you said. Like the press asks seemingly weird questions because they're trying to dumb it down for people, you know, that don't know too much about spaceflight. Yeah, we know that. However, I watch a ton of these press conferences. There is no way that some of these people that ask these questions, A, listen to anything any of these people have to say. They just ask a question and shoot from the hip, even if they answered it already, because they want their question answered. Or B, are being deliberately obtuse because they're trying to get a story. Those two are what piss me off. I really don't like that. If someone's coming, like Stephen Clark had a great question from Spaceflight Now. He had an excellent question about how does this affect your concept of operations for future Dragon recoveries. That is somebody that you wouldn't ask that question unless you were genuinely interested in the subject matter, which Stephen Clark is. He's been doing space news like almost as long as I have. He's been covering it, right? And that's a really good question to get a really good answer, and you could write a really good story about it, right? Some of these other questions are, once again, they're trying to do a gotcha, and I hate it. I hate it when people do that. I can't stand it because all that, gets reiterated is just what they said before, and you're wasting everyone's time. We only have a finite amount of time to have these subject matter experts on a panel where you can ask them any question you want about ISS operations, Crew 9, Dragon, the Falcon 9 RUD, even stuff about Starliner. And somebody chooses, well, do they need to land to get the capsule certified? That's the question you ask. Thanks for wasting everyone's time. Really appreciate it. Dude, I've listened to enough of these to know some of these people ask these stupid questions on purpose. It's really annoying.
Jim, we have a couple products that will be released soon that go in depth on the science launching on Crew 9 as well as on NG, so I'll be sure to pass those along. All right, next up we have David Nault with About Today News.
Like, dude, I know enough about this to know who's asking a gotcha question and who's actually there to learn stuff. And genuinely, like, most of the questions are pretty good, but every once in a while you get one that's just, dude, you just want to hear yourself talk. It's so annoying.
I want to come to the question again about the Polaris Dawn mission. Sarah, when was the decision made to pull the mission from the August 31st And last I checked, it was still on their site for launch. When was that pulled? And how late in the summer would you think this would go? Would you think into late August or September?
What?
Yeah, thanks for your question. I do think that it went to the range to change the launch date for Polaris yesterday. No. Okay. It's all happening this week is the bottom line. What we did is we pre-planned rules of engagement between the two missions to make sure that both customers could fly in the right time. Number of days for weather, number of days for each operation, per pad turn, all of that stuff. And so we've been working with both customers. Right now, we're still protecting for an August launch of Polaris Dawn. And so, yeah, I guess that was your question, August or September. Right now, we're still planning to launch Polaris Dawn in August. And yeah, and then I also wanted to circle back to a previous question about West Coast and East Coast. I forgot to mention one benefit of moving to the West Coast is much better weather. So we have a number of sites in Florida that we feel like we're sometimes threading hurricanes a lot. And when we looked at the flight rules for wind, rain, wave height, all of the criteria that determine our flight rules for return, we actually saw that the West Coast sites that we're looking at have much better weather, which allows us to have much better return availability. So that's one thing, just to go back to the previous question, that we're looking forward to.
It's awesome when you get somebody on the panel that really wants to be there. Like Steve always answers really well, and I'm blanking on the ISS Ops manager's name. Ken and Sarah too. Like, you get people that are genuinely pumped about space, like she is, and you get really awesome answers. You know, Dana, that's her name. Thank you, Red Fox. Yeah, Joel Montalbano's like that. Yeah, even Mark Nappy, the guy that runs the Starliner program over for Boeing. Yeah, these people genuinely want to be here. They're not like there for another meeting, which is super cool. Yeah, like I love hearing these people talk. Like, especially when Steve talks, dude. You learn a ton about where their mind's at and what they're thinking about. All of my explanations on how you go about like risk aversion with spaceflight, I learned from listening to these. Like, straight up, dude. I don't have any mentor, you know what I mean? Like, I mean, I have a couple that work in the industry, but these press conferences give you very valuable insight just as to how NASA goes about conducting spaceflight. It's so important to listen to these. You learn a lot. And like Sarah, she clearly wants to be there. Like, she's like, oh yeah, let me answer that other question that was asked like 5 minutes ago. Oh yeah, another benefit, boom. And now I learn all this stuff. I learned a lot of good stuff about Dragon, you know, like wave favorability, wave height favorability during recovery operations for Dragon capsules on the West Coast, right? Dude, where else are you going to learn that stuff? You ain't going to learn that stuff anywhere else. This is the place to learn.
Thanks, Sarah. Next up, we have Douglas Gorman with Payload.
Yeah, hi. Thanks for taking my question, being so transparent about all of the changes. My question is about the anomaly. So I know, Sarah, you said that you would be taking out the sensing line that caused issues on the last Falcon 9 launch.
Not the sensing
line.
What
do you lose from having that sensing line gone? Is there going to be less data on future launches? If you could just explain more of what's going to be missing from that data.
Sure. Yeah, that's a great question. Most parameters that we're watching in flight, we have 2 or 3 or more redundant sensors. And so I mentioned the near-term action was to just remove that line. That's actually a good point that maybe will be a helpful clarification. So while the FAA investigation is complete, what that means is we know what caused the problem. We've looked at all of the systems to ensure separation, and we've agreed to a set of actions to take going forward. Yeah. That doesn't mean that all of the actions have been taken yet. And so I think we'll just remove this one sensor from the data set for the near term so that we can fly with all the sensors that we have. And then there's further steps to continue improving the fleet as we go on.
And I would add, from a commercial crew perspective, for us, that sensor is more critical for some of the more aggressive flights that SpaceX flies that require multiple burns out of the second stage. For us, we have one long burn after first stage to get the vehicle, the Dragon, inserted into orbit. And so for us, the sensor isn't as critical. It helps with a little bit with determining the next burn and how the next burn will be executed.
Thank you both. Next up, we have Ryan Catan with NSF.
Hey, Ryan. I know that guy.
Hi, thank you. This is for Steve. Does NASA have to approve next week's Starliner readiness review before the crew plans for Crew 9 can be finalized? That's assuming, based off the information in the presser yesterday, that Crew 9 could be considered for a backup return vehicle. Thank you.
Good question, Ryan.
Yeah, we're really working toward readiness review for the Crew 9 for CFT return at the end of next week, hopefully. We'll get through that, and then we'll proceed into the rest of the manifest with the Crew 9 launch and then the Crew 8 return. So it's a pretty busy time for commercial crew. It's a pretty busy time for Dana, but we're working through the Starliner investigation, getting through the final, as I talked about yesterday, the final parts of that investigation, and then heading into the agency readiness review.
Thank you. Our next question comes from Stephen Clark with Ars Technica.
Yeah, I was just about to say, guys, that's why I like doing work with NSF. That's why I work with them, because NSF does their homework, and they're not there for a gotcha question. Ryan is there because Ryan is a spaceflight nutcase, and he genuinely wants to know. Like, he's interested in the certification process. Do you see the difference in the tier of questions between him and, like, what Ryan asked and what, when does Starliner need certification? Like, that, do you see what I'm talking about? That's why I work with NSF. Those guys and gals are really, really talented. They're really smart people, and they give a frick about spaceflight. Like, that's the big one. They care. It's not just work. It's fun. You know what I mean? Also, Doggo.
Hi, thank you. I just had a quick question on the manifest for the rest of the year, Dana. You didn't mention AX4. Where is that going to fall? Is it now next year? Thanks.
Yeah, we're still holding that flight no earlier than November, and so of course we'll adjust if we need to as we look at the manifest and where things really lay out, but for now we're just holding it there.
Thank you. And we do have another question here in the room.
Hi, Will again with Spaceflight Now. Believe question for Sarah and perhaps Steve as well. I think it was Bill Gerstenmaier that said last year that the next Crew Dragon spacecraft would be brought into the circle this year. It seems like that's not happening. Is that still on tap for this year or perhaps next year? Can you just clarify that? Thanks.
Oh.
Hey, yeah, that's not the Dragon that we're using for this mission, but it's almost done. And so I'm not sure if it's late this year or next year that it will be a full-fledged member of the fleet, so to speak. We'll have 3 cargo vehicles and 5 crew vehicles at that point. But yeah, it's nearing completion.
That's awesome.
I can't remember if it's still in our Hawthorne facility or I think it's still in our Hawthorne facility in the Dragon clean room. But it'll be moving to Florida shortly for just final preparation for whatever mission it gets assigned.
Yeah, right now, I mean, that Dragon is at Hawthorne. It's getting assembled in the clean room. It's going through its final preparation. Right now, it's slated for Crew 10 in February. So we'll have it's exciting to have another brand new Dragon spacecraft for Crew 10. That's the plan right now. So
that's so cool, man.
Thank you both. We have Bill Harwood with CBS News next.
No, Forge, I haven't seen it.
And this is for Sarah, I think. I'm just out of curiosity. I'm not sure I understand what an engine hard start means in this context. Did the engine break up? I mean, was the state...
Hard start means it exploded. That is a industry way of saying... Well, that's actually not true. Hard start means you basically are getting a detonation in the startup sequence before ignition. And that detonation is hard starting the engine because a detonation is a lot more violent than the deflagration that happens when a rocket engine turns on. So what can create a hard start? Improper mixture can create hard starts. improper mixtures during the igniter sequence, during the ignition sequence. So usually how a rocket engine works is they open up pre-valves, cool the turbine machinery if you're using a cryogenic propellant, and then you start flowing one using ullage pressure. And that can basically, hey, knocked over my calculator. That causes basically a chain of events that, I'll be real with you, it has more in common from what I understand with a Rube Goldberg machine than it does with like what you'd think a rocket engine does. But like there's springs and gates that open with springs from residual pressure that basically will start flowing liquid fuel and oxidizer into the engine. Now, if one of those things is a little bit out of whack and you go fuel rich or you go oxidizer rich during ignition, you'll detonate. You'll make a detonation wave inside of the rocket engine. And that detonation wave can exceed a chamber pressure inside of the rocket engine. So a detonation, like if say a rocket engine is rated for 100 bar, like 100 times atmosphere inside of the combustion chamber, that detonation wave will make like a 200 bar pressure wave inside of the combustion chamber just for a split second, but that's all that it takes. And then it'll just blow it up. What the hell is he doing? Hold on. What are you doing? What are you doing, Titan? What are you doing? You want me to play? You want to play? I'm listening, but I can't stop giggling, dude. I'm getting so distracted. All I hear is whoo, whoo. It's freaking Chewy toy bouncing around. Hey, his Chewy toy is space themed. See, it's the sun, the earth, and the moon, and they squeak. Dude, it's a solar system, all right? So it's topical. Look at this. Look at this. Come on. Get it. So, yeah, here. Let's see. I'm going to let them talk for a second. Holy crap.
It's still intact after that. I know you lost attitude control, but what exactly happened when the hard start occurred physically to the rocket? Thanks.
Sure. So while the propellant and liquid oxygen were flowing to the chamber, there's a third thing you need, an ignition fluid called TTEB. I'd mess up if I tried to say the names of those chemicals in public, but TTEB is the ignition fluid that comes into the chamber. And it moved through its line because it was too cold, too slowly. And so without that ignition fluid present at the time when the fuel and the oxygen started mixing, that caused damage to a number of components on the engine. It was not widespread damage to the entire stage itself, as we saw by the stage still continuing to send telemetry throughout the whole operation, deploy the satellites, passivate itself. But there were a handful of components on the engine that were damaged, which did not allow it to complete that second burn.
Our next question comes from Jeff Faust with Space News.
Dude, I mean, in this particular case, they have to mix the triethyl aluminum and triethyl borane. So TTAB, what Sarah was saying, they didn't get the mixture right because you didn't get your starter fluid in there. That's like trying to run an engine without a spark plug. I mean, if it's diesel, then yes, I know someone's going to hit me with the technically. If it's a diesel, then you don't have to worry about that. A gasoline engine that needs a spark plug, if you try to start it without a spark plug, you're going to make a lot of problems. If a car engine backfires, is that a hard start? No. Car engines can do that, but a rocket engine and a car engine use slightly different forms of compression as the result of combustion. It's called adiabatic compression versus I forget what the rocket engine does. Long story short, the car equivalent is rod knock. So you guys, everyone here has heard of octanes for fuel. A higher octane fuel can take a much a car needs higher octane fuel because of the compression. If you run low octane fuel, if you run like 87 in a Ferrari, you're going to get rod knock. The reason why is because you'll basically detonate the fuel before the spark plug goes off. And in this particular case, the rocket engine, you get a detonation wave flying through the combustion chamber, it'll blow up. With a car, you'll get that same detonation wave hitting the piston before the piston gets to top dead center, and that's extremely bad for it. That is terrible for an engine. That's why it's called rod knock, because that detonation wave is knocking against the connecting rod, because the piston absorbs that wave on the way up, and it compresses the rod. And you compress the rod, you're basically shock loading your piston and your rod and your bearings. That's the real important part in a car engine. Now you've compressed the bearings on the piston, on the connecting rod journal, and you've compressed them for a second. That makes them very upset. You basically squeezed all the oil out of that like a sponge, and now there's no oil in there. Yeah, it only takes a little bit of rod knock to blow up an engine. Or you could bend a piston, you could bend the connecting rod. If you bend the connecting rod, you're screwed. You're screwed. It's very rare that... Oh, buddy. Oh, buddy. It's very rare that... What's wrong? What's wrong? What's wrong? What's wrong? What's wrong? Blue Flare, I saw what you said, by the way. That just made me happy. What's wrong, Taito? What's wrong? Oh, he's so happy. Oh, boy. You okay? Hey, no piranha puppy. No piranha puppy, dang it. If you bend a connecting rod in a motor, you're screwed. The engine, you're not getting out of that without an engine exploding, like an engine rod. He doesn't like vent rods. Well, who does, Cone Man, right? Like, I can't blame him. He's definitely my dog. Hey, come here, buddy. Come up here. It's okay. I love this dog. I love this dog. He's a good boy. He just wants pets. He just wants to be pet. You're a good boy. You're a good boy. You're a good boy. Do you like spending time with Daddy at work? It's take your dog to work day. Just use a Wankel. No rods required. You can get rod knock in a Wankel engine. It still uses adiabatic compression. You can, I'm looking at the wrong camera. You can still get rod knock in a Wankel, and I assure you it's not pretty. Is Titan a mutt? He is a mutt. He's a cattle dog mix. He might have a little bit of other dogs in there, but he's mostly cattle dog. See last. More Wookiee noises. Yep. Stay. Excuse me. There, we spooled the turbo. I hope I'm not allergic to you, pal. That would really suck. But I get over it because I love you. Anyway, yeah, a little bit on compression. I'm allergic to my dog and cats too. It isn't so bad. Yeah. I don't care, Adele, to be honest, right? I don't care. What time did you feed him? I fed him this morning, but I've been giving him treats throughout. He just wants to play, that's all. Here, go get your ball. Go get your ball. Get your ball. This said he diet of daily allergy meds. Yeah. What's up, buddy? What's up? Come on. Oh, he's a good boy. He's a good boy. He's a good boy. You're a good boy. Titan, you're a good boy. Oh boy. Oh, boy. He's a good boy. Huh? Oh, boy. I don't want to get sued for talking like this too much. Oh, boy. We didn't name him after a dwarf planet, guys. We didn't name him after a dwarf planet. We named him after a moon. Or a missile. I prefer the missile. beer. All right, let's finish up with this presser, and then there's more space news.
Yes.
Quick follow-up question.
It is
for
CW,
Sarah.
for sure.
You mentioned removing the sense line as a near-term fix. What are you looking at in terms of a long-term fix, and how far long-term might that be? Thanks.
I'll give you 3 guesses to what this answer is. We don't know. If we knew the long-term solution, we wouldn't call it a long-term solution. They got to figure it out. That's what Sarah said a little bit earlier.
Hey, I think that the full report from all of our work with the FAA in the last 2 weeks is coming out. I think it's made public very soon. So that'll have a ton of details in it. But I think there's a number of actions that will be coming up for us in the coming weeks.
Told you.
Thanks, Sarah. And the last question we're going to take today is from Joey Roulette, again with Reuters.
Hey, thanks. Another quick follow-up for Sarah on that. How did the satellites deploy? I know you said the second stage wasn't completely lost. Was there some kind of emergency deployment command that was sent when there was a problem with the engine, or what happened there? And then for Dana, has NASA asked Russia anything about why its old satellite blew up in space or broke apart in space last month, or has Russia provided any explanation into why that happened? And if so, what was that, and what's NASA's?
See what I mean about wasting people's time?
Understanding of that. Thanks.
Yeah, so for my question, that's a predefined, I'll say, operational sequence. The stage is programmed to sense either successful completion of the burn or confirmation that the burn has not or will not complete nominally. And then once one of those two things happen, it steps into its next state, which is to deploy the satellite. So it's the same deploy sequence that would happen had it been in the higher orbit, and the predetermined outcome that happens really in any scenario.
See, you guys are right. It's not the worst question. That first part is not the worst question to ask. That's actually pretty fair. But Sarah did clarify that the stage, basically in her opening statement, she said exactly what happened. Now that second question, what the hell are you doing? What? What are you doing? What? What? You've been balling with me all day. You want to ball some more? Go get it. Hey, good catch. Titan's not, see, guys, you know what it is? You know what it is? Titan is not happy with these questions. See, that's why he's gotten all bent out of shape. When the good questions are being asked, he was fine. What? That's real. That's what's really going on here. Anyway, let's see how they answer this, and then we'll get to it. I got, guys, yeah, here. I have another thing to show you after this, and maybe it'll put it in context of what's going on. Part cattle dog. Oh, he's always got energy, Explorer. That's just how he is, dude. I've had worker dogs before. I know how it is. That's why I've just throw the ball with them. To
answer the second part of your question, that satellite that broke up had been out of service for quite a while. It was just orbiting. And taking a look at how it broke up, it looks like a pretty typical satellite type age-based failure. Satellites can have any number of issues, especially when they're not in service or actively moving or avoiding things like debris. So for example, you could get a micrometeoroid strike, and depending upon what you have on the satellite that's still pressurized, whether that's tanks, fuel, other components, you can get a breakup. And so for us, it very much looked consistent with what we've seen with other satellites that can have a breakup. It was when we have something like that that's in the proximity of station, of course, we take very conservative actions until we get enough data and insight about the pieces that have broken off and where they might be heading. So we did have the crew shelter, and then after that pretty quickly got data and realized it wasn't a big risk or threat to us. But I think to answer your question, it looked like a very kind of typical satellite breakup, so we weren't worried that there was any other kind of explanation for what we saw with that satellite.
A super good answer from Dana, but you can tell, guys, I'm telling you, the eyes tell everything. We're borderline dagger eyes there. If you know, you know. It's borderline. It's like, I hate this person. Like I said, the eyes tell all, dude. Eyes don't lie. Anyway, yeah. So that was the press conference. That's an engagement. Those eyes haunt me. Yeah, Hippo. If you know, you know. That's a dude. The eyes don't lie. I'm telling you, the eyes don't lie. And this isn't just like a one or the other thing. The eyes don't lie in a relationship, man. They don't. The eyes have it.
Thank you, and thank you all who submitted questions.
Anyway, some really good questions there, some really not good questions there. But anyway, I'll show you guys what I mean when I say that these people are sometimes asking questions that are just deliberately just trying to get them to say something stupid, like, and they're not. They're NASA scientists and NASA engineers and SpaceX engineers. Like, they're not going to do that, but they still do it. Anyway, so sweet press conference there. Here. So here's an article from the same dude that asked those questions. Look, this is an article from Joey. This is why I'm like, Joey, come on, man, because he writes this awesome article about a Reuters exclusive here about SpaceX in talks to recover Starship off Australia's coast. Rip bed and green screen. Titan, why did you eat your bed? Well, that was fast. Why did you eat your bed, buddy? Jeez. Excuse me for a second here. I'll talk and pick this up at the same time. Why'd you do that? You know this is where you sleep out here, dude. Hey, stop it. No, the stuffing isn't for you. The stuffing isn't for you, doggo. No. Oh, don't hit me in the face. Jeez. Golly. Come on. Hey, let it go. Put the bed down, dog. Put the bed down, dog. You're tripping, dog. You're tripping. He beat the stuffing out of this thing. Holy crap. Here, just play with the ball, dude. Holy crap. Anyway. He dropped the ball in his water bowl, and now he's confused. You got it? You got it, buddy? You sure? We have a whole week of this. Hey. Oh, God, he's... Why do I keep doing that? Now your bed's not going to be comfortable, dude. All right, so check this out. We're going to switch gears, and this is Joey again. This is the same dude that asked those questions, and I don't understand how you can write an awesome article like this and also ask those kind of questions. The one-ear flop is too much. I know, for real, dude, for real. SpaceX is in talks with Australian officials to land and recover one of its Starship rockets off of Australia's coast. A possible first step toward a bigger presence for Elon Musk's company in the region as two countries bolster security ties, according to 3 people familiar with the plans. At least 3. No more. Not 4, but not 2. 2 is not enough. 4 is too much. Okay? See last for nuclear stuff. That's the Starliner thing you talk about. All right, I'll check it. 5 is right out. Yep. Yep. Since the Starship rocket made a controlled splashdown for the first time in June in the Indian Ocean, SpaceX has been eager to expand its testing campaign. Successful landings and recovery of the boosters afterward are important elements of the speedy development of the giant reusable rocket designed to launch satellites to orbit and land astronauts on the moon. The plan would be to launch Starship from Texas, land it off the Australian coast, and recover it on Australian territory. Getting permission to do so would require loosening U.S. export controls on sophisticated space technologies bound for Australia, according to sources who spoke on the condition of anonymity. Why not just do it in the Dragon recovery area off the Cali coast? They're worried about shipping lanes, Katra. In the future, Starship will land in areas that are like the capsule, but you don't know if this thing's going to break up during re-entry, and you definitely don't want it breaking up over a major shipping lane, having parts fall on or near a container ship from another country or anything and cause an international incident. That's the reason why they chose to deorbit it in like the Indian Ocean off the coast of Australia, because there's not a big shipping lane there. True story. I thought the plan was to catch Starship with a tower. Eventually, yeah. Rockets, yeah, of course. Eventually, it'll move to that. But for right now, you don't know if the thing's going to break up. I mean, you saw Flight 4. I am still amazed there. That was like an act of God that thing made it through re-entry. It was ridiculous. That thing should not have made it through re-entry. There's a hole in the freaking wing. And it's just like, yeah, whatever. All right, I'm still good. It's fine. We go to land now. You know, like... 20% luck, according to Elon. Dude, that was an act from the Almighty himself. It was ridiculous. Ridiculous. Ship is due for a boost burn this time. Yeah, there you go. Gotta walk before you can crawl. Yep. SpaceX and the U.S. Space Force and the Australian Research Space Agency, or the ARSE for short, did not immediately reply to requests for the comment. Towing Starship after it has landed in the ocean or on a barge to a nearby port on Australia's western or northern coast would be ideal. Perth is where you'd want. That's the only thing that's out there. 20% luck, 80% fly, baby, fly! Yeah. The Almighty himself. Bruce, Carrie, Jim, Steve, Carell. The conversations underscore the U.S. determination to help Australia build up its military as a deterrent to an increasingly assertive China in the region. China. Or point to point, the Almighty himself, Mr. Morgan Freeman. I think we should read the rest of this in his voice. That would be great. The conversations underscore the U.S. determination to help Australia build up its military as a deterrent to an increasingly assertive China in the region. The proposed SpaceX arrangement would put more trust in a close American ally that for years has sought to expand its space defense program, strengthening civil and military space ties with the United States and stimulate its own industrial base. Yep. This article's getting a little too speculative for me, but yeah, still cool. If that's even if there's a modicum of truth there. That would be modicum of truth. Good for me, dude. It's not really say that word. Whatever. Anyway, see, that's a remotely decent article there. I don't know why Joey asks those weird questions. It's very strange. So, in other news, record scratch, blah, and now on to something completely different. Check this out. Look, we have an FAA document to review, and it's oh my God, it's 154 pages. What, 150, boom. What, 154? No? All right, cool. What? Where are you going? Come back. So you know what? We're going to do the right thing and just scroll all the way to the pictures. Da, 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 da. Real quick, before I go, the FAA document mentions a breakover fixture for the ship. What? Damn. This is the part I wanted to see. I don't know about you guys. That is the plans for the second pad. It looks like they're building a new gate here, the D2 gate. And then there's the D1 gate, and then there's the Sugan D gate. What? It looks like Elon's been consulting Professor Sugan. Professor Sugan D's nuts. No, this shows a clear drop-off point right here for the second pad. Integration tower. Wait a minute. Wait a minute. Where's the pad in this diagram? The pad's gonna... Where the birds nest. Trick question. The birds don't nest there. Am I missing it? Probably isn't finalized. Middle of the pink. Oh, OLM2. That's a... I'm just noting the distances here between OLM1 and IT1 and OLM2 and IT2. I think it's going to be like right here. I mean, either way. Well, we do have the commodity trenches here. And it looks like the tank farm will be able to service either pad, which is actually pretty cool. Flame diverter collection pond. Yep. Water farm 1, water farm 2. You can see the tower behind the polygon. Oh, I know. Yeah. Here, dude, I know. Like, I'm just wondering where the pad is going. That's all. Like this, see this big piece? That's too far away from the diagram. And, you know, before you say, oh, it's just some artistic license, right? Like, I'm pretty sure an FAA document should get that relatively right. Damn, that's cool. This is getting out of hand. Now there are 2 of them. To the south. Yeah. Gotcha. That was courtesy of our buddies over at NSF, Starbase Live. Go subscribe to it. It's a live stream of Starbase 24/7 if you're interested in this kind of stuff. There's the landing corridor. Yep. Yeah. Indian Ocean Starship landing area. No, that's the Northeast Pacific landing area. Yeah, see, that's the landing spots near Hawaii. That's where they targeted originally, right where my mouse cursor is for the most part. Yeah, they could land one potentially off the coast of California. Southeast Pacific. Oh, they could land one near Chile or Peru. Cool. These are all the potential spots for landing sites. Okay. This is the access restrictions area during a launch. Okay. Oh my gosh. Walls of text. I should probably read through all of this, but also... Hey, Laglander! How are you doing? All right, let's find another picture. Oh, yeah, this is the theta, the rocket noise. That's the angle that the rocket noise can take with trajectory. That's cool. Hello. Interesting. Okay, I'm going to review a little bit of this off stream, okay? That seems to have the EIS stuff in there. We've already seen that. I could spend an entire stream looking through that stuff, dudes. That's my homework. What is this? What is this, Forge? The new long-awaited flame trench for the new launch pad at SpaceX is slowly showing signs of itself, with sheet piles being hammered into the ground in a line along the tower's face. I have made 3 versions with various... Oh, so it is going to have a flame trench. I mean, that doesn't call for it, but all right. This is coming from Chrome Kiwi here over on the Twitters. Dude. See, you can get away with that over here on this side because that's where SpaceX built up a lot of soil originally. You could get away with building a flame trench there. This is all elevated. Triangle in the bottom left. Flame divert. That's the collection pond, though. Aqualex, is it not? Am I not looking at this right? Dude, please, Soyuz style would be awesome. That's super cool. Is it a flame diverter / collection pod? I don't know, man. Flame diverter collection pod. Yeah, I suppose you're right. But per these renders, wouldn't it be like all of this? If I'm looking, okay, so I'm talking it through. I'm not disagreeing. I would assume that in Chrome Kiwi's render here, this thing right here, that is this. Does that make sense? So yeah, and that could be the reason why there's so much area slated for OLM2, right? Because what part of this is diverter and what part of it is trench, right? What part of it is retention, right? That's the wetland boundary. Yeah. Dude, that would be gnarly. Dude, I want this one. The Soyuz style diverter would be fantastic. Soyuz always gives a great visual during launch. So Chrome Kiwi said that, let me read what he said again. Oh, that dude follows me. I follow him. Yo, what up, Chrome Kiwi? Cool. They're building a wall so they can reinforce the soil. They're digging a bit under the pad. My only problem with it is that SpaceX wants access to the engines at all times on the pad for inspection of the dance floor, so it will probably end up being like this. Oh, this is a bomb freaking render of Slick 34. Or that's Slick 37, excuse me. Yeah, dude, removable flame trench. I love, dude, the way Apollo did it was right. I don't care what anybody says. Apollo had everything on a pedestal. And you could remove the diverters out underneath it if you needed to get at the engines. It's genius, dude. He does work for RGV. Oh, right on, dude. Right on, right on. Josh, what's that? Generating radio frequency with photonic oscillators for low noise. Oh, cool. Yeah, here's the same pad. Yeah, that's just a crop picture of the picture that's on Wikipedia. But yeah, Apollo had it right. That's the way to do it. With a retractable flame diverter. That's really smart. And SpaceX is very wise to follow in their footsteps. Von Braun knew a lot about this stuff. Couldn't the shuttle also change out engines at the pad? I don't think so. I really don't. Hey, Blue. Well, that'll drastically miniaturize microwave transmitters. All right, we'll get to that in a moment. Anyway, yeah. That's cool. I don't remember following Chrome Kiwi, but that guy seems neat. I was going to say, I kind of doubt you're going to see something like this. Just because, oh, actually, you might. Sonic Boom updates. Yeah. I have that teed up. We have a lot of stuff, Phil. You guys are linking faster than I can talk. RGV. Okay. Other Phil. I got this one. Let's take a look. Oh, yeah. Yeah, I see exactly what you're talking about. Yep. See the pile driver? Yeah. This is the RGV aerial picture. Yep. Yeah, right there. See those holes? They're reinforcing the soil. You'd usually do something like this if A, you were building something structural here, or B, you were you were digging something right here, like what Chrome Kiwi has. I like that design. I think that would be sick. Who funds RGV? Patreon? I'm pretty sure it's Patreon supported, Blue, but I could be wrong. The entire area towards the corner is filled with piles. Really? Where? I only see them right here. It's going to get picked up where the crane is, Sea Kraken, per these plans. See, that's where the crane is right now. The entire OLM is being redesigned. So here's my thing, dudes. What are we talking about? SpaceX's new launch pad. So here's what I'm thinking. All right, so Chrome Kiwi has these pictures here. I look at this, and I just say, why not just put the OLM right there and give it longer supports? Think about it. Why not just do that? Just put the OLM right here and make the legs of it a little bit longer. Why even have this backing wall right here? You just build the OLM halfway over this trench and you're good to go. Right? No. Yeah, no, it's very unlikely. What is an OLM? It's the orbital launch mount. It's the thing that holds Starship down to the ground, Bog. It looks like a donut. Here, let me bring up Starbase Live. I'll show you. It's this thing right here, the thing that Starship attaches to. How hard is it for them to just buy more land? There's only certain land you can really build on out here, Sig, because of the water table. The Rio Grande Valley is kind of swampy. Are we waiting for a launch? Not right now, no. I'm just reviewing an FAA document about this, about Starship. Guys, I'm just gonna float a weird one. I'm looking at this, right? I'm looking at this, and, you know, we were talking about Apollo, right? How a launch pedestal or a mobile launcher would be the right way to do this, right? That, you know, a pedestal where you can get at the engines, you can move it around really, really easily. And, you know, a couple people said that the OLM is being redesigned. You so badly want an ML for Starship. Yep. Redoing the OLM to make it a mobile launcher platform would set up 39A for Starship in the future. Not saying I don't want that. Combined OLM and transport mount. It makes sense. Look, man, Apollo had it right. The best way that the Apollo engineers, with a blank check from Uncle Sam, the best thing that they could come up with to efficiently move rockets to the pad was to move the entire freaking launch pad with it. Now, you're not doing that with the orbital launch tower. You're not doing that with the integration tower. That's like moving the entire VAB. But the OLM isn't. The OLM works a lot more like a mobile launcher platform, like the space shuttle. I'm telling you, man. I'm sorry, ML for Starship ain't happening. I'll bet $1 on that. Yeah, well, you know what? I'll bet a timeout on that. Oh, wait, you lost. Timeout. Shut up. I can dream. Be quiet. Stop talking. The tower is integration, though. Bingo, so you wouldn't move it. No, I mean, they're going to redesign it. Dude, you can't look at this and tell me that this doesn't favor a mobile launcher. Any of these designs don't favor a mobile launcher. All of these designs favor an ML. Every single one of them. Every one of these things that Chrome Kiwi is working on here. You don't want $1? No, I want you to stop talking. Was I not clear about this? Hopium, all the hopium. Why don't you take some shut the heck up-ium, all right? And maybe shut the heck up. Right, Titan? Right, buddy? Yeah. Right? Hey. Oh, you were sleeping. I'm sorry. Go back to sleep, boy. Oh, you want the belly rubs? He wants the belly rub. I love you too. You want the nice belly rub? Hey, who put your bed back together after you ripped it apart? Isn't it nice and comfortable? You want the belly rubs. He wants the belly rubs. Get up on the film. I love you. See, Titan says you need to shut up. He needed the belly rubs. Winding him up. Winding him up. He's a nice belly. All right, go back to sleep. Go sleep, B. I love you. He wanted belly rubs because I woke him up. That's fair. That's fair. That's fair. I think that's okay. Elon to me would love an ML. I want an ML. Look, okay, I'm sorry. It is hopium. I just want to see a starship roll out of the VAB. Nothing would make me happier than seeing the VAB get actually used like the Apollo engineers wanted it to be used. Here comes a rant about the VAB in case you didn't know. Okay? Here's the thing. The VAB, the Vehicle Assembly Building that NASA built for the Apollo program right here, has 4 bays and is capable of stacking 4 rockets all at once. You could do checkout and integration and processing for 4 Saturn V's. The whole launch pad will move and they'll tow it out here and they set it down with the crawler transporters. Now, I know what people are going to say. What do you mean, the crawler transporters? Aren't those things slow? Yes, their top speed is a half mile an hour with no payload. With a payload, it's like 0.2 miles an hour, right? But I will contend to say that 39A was designed to launch on the daily. Yeah, you heard that right, on the daily, maybe weekly. It was designed to basically be a rocket launching assembly line. You don't build 4 bays and build 3 mobile launchers and 2 launch pads to not launch a lot, okay? Right? Make sense? With that being said, this thing never even got close to its operational capacity. Never even got close. The maximum the maximum it got was 4 launches a year. And that was the VAB being utilized maybe at like 20% of its like usefulness. That was 4 times a year. That was 1960. So 4 times a year was 68, 69, 70, right? That's not even close to maximum capacity of the VAB. The VAB could build 4 Saturn V's. You could probably launch 4 Saturn V's a month with the VAB. And I know people are going to say, EJ, aren't those crawler transporters slow? It only takes the crawler transport 6 hours to get out to the with a payload to get out there. It doesn't take very long. It wouldn't take any longer than SpaceX towing the thing on a towing Super Heavy and Starship on the SPMTs. Those go slow. Nobody bats an eye there. So what I'm trying to tell you is that this thing was designed to launch, and it was designed to launch a lot. And it would just really make me happy to see somebody actually using it for what it was designed for. It just pisses me off that NASA's okay with, and it's kind of out of their control. It's really annoying that NASA's okay with maybe one launch a year. One launch a year is like doing Uber with a freaking Formula One car. It's just... Yeah. It's hard for me to cope with that, okay? So that's why I'm hitting the hopium, all right? I'm hitting the hopium and hoping that SpaceX switches Starship to an ML design. That's a lot of pilings, dude. This is another picture from RGV from the other day. That is a lot of pilings. Interesting. Interesting. Huh. Strange. How much concrete and rebar do you want? Yes. Yes. Nice cat right there. Nice telescoper. Small lattice crane. Big lattice crane. That's a lattice crawler with power boom attachment. That's designed for lifting extremely heavy things, if you're wondering. And designed for not as much deflection. You don't want the crane to buckle sideways when you go to lift something like a tower segment. Would NASA allow SpaceX to lease a crawler? I don't see why not, Nova. NASA has been deliberately keeping the High Bay 1 solicitation and Crawler Transporter 1 kind of just in limbo. Now, let's be real. If SLS flies on a one launch a year basis, you definitely ain't using those. So, meaning they might be surplus. Stupid question. They're worried about things tipping over, and that's why they go slow. Why don't they just strap it down? Strap what down? What are you talking about? The rocket's on the crawler transporter. What do you mean strap it down? The crawler transporter is carrying a mobile launcher, Flyken. That's the launch pad. The rocket is bolted to the launch pad. Is that not strapped down enough for you? The crawler transporter can't go any faster because at that point, I mean, dude, if you have a faster way of moving 15 million pounds around, you let me know. Call NASA. You'll probably get a job. Omega would have used the VAB. Yep, RJ would have. And you know what the hilarious thing about that is? Northrop Grumman pulled out of the Omega program because they said there wasn't any money with it, and they said, Antares is good enough right now. And then they stopped getting engines. Good move. Just put nitrous on the crawler. I have a way that doesn't involve explosions. The SBMTs are pretty quick. Yeah, they can move at like 1 to 2. What is it? Like, nah, it's not 1 to 2. It's a little faster than that. But that's just moving a super heavy or empty, might I add, or Starship. As try moving 15 million pounds worth of launcher and launch vehicle that's fueled, well, partially. If anybody has a quicker way of doing that, yeah, let me know. What that doesn't sink into the ground. They use the crawler transporter for a reason. Because when you just get to this scale of rockets, you just need ridiculous solutions like moving the entire launch pad. Could you cover how the VAV was intended to be extendable so they could still fit the stretched... The roof of the VAB is made to be built up in case NASA wanted to build a bigger rocket. It's built like an erector set on purpose. You can extend the roof if they really need to. Just like what ULA is doing with the Spock building for Vulcan. They're extending it so they can put another VIF in there. Didn't the VAB get to its max capacity with the shuttle program in 1985? Nowhere near it, Nova. They only retooled High Bay 1 and High Bay 3 for the shuttle program. They only retooled those. That's it. They didn't use High Bay 2 or 4 for launcher integration. Nope. If anything, it got maybe close to half capacity. We know that half capacity, right? Because the shuttles, right? Actually, that's a very good point. We knew that the shuttle was going to launch 24 times in 1986, and they were well on their way of doing that. 24 times, right, would be 2 times a month, or every 2 weeks. We know they planned on scaling up the shuttle, right? They planned on scaling up the shuttle missions to 48 times a year. They wanted to launch once a week. That's why they built 4 orbiters. Shuttle takes a month to refurbish. 4 orbiters, you launch once a week, right? So I think using some reasonable logic extrapolation, we can pretty much determine that the VAB operating at half capacity, excuse me, the VAB operating at half capacity could support 48 launches. Can you imagine if it was cranked to full? You could, the VAB with the crawler transporters could support daily launches if all 4 high bays were being tooled for 1 rocket and you scaled your production line sufficiently. It's pretty nuts, right? That's what I mean, dude. That's how well built, that's how smart the Apollo program was. It was so smart. Oh, Von Braun's a freaking genius. Like, dude, oh, it's so frustrating. This is why I want to see Starship use it. Because I want someone to put that stupid building to use. Use what it was designed to freaking do. Oh, 1 launch a year. Give me a freaking break, dude. 22 cars. And a boat. How did you sink a boat? Would need on-site oxygen and hydrogen and methane plants running 24/7 too. Would it piss you off, Deadbringer, if I told you that they built those? That's not the only one. There's more. There's another one. There's another one in Mims, just north of here. Yep. That's a lot of power coming in. Bro, the Apollo program wasn't just about building launch pads, homies. Where am I? I need to go to PSJ. Yeah. Guys, when they did the Apollo program, they built out the entire infrastructure to support this type of operation. There are like multiple power plants on the Titusville coastline. Guess where those power lines go? There's one there, and then there's another one up here. Where is it? No, maybe it's south of here. Oh, there it is. Have you ever done scuba? Nah, that doesn't really interest me. So build an on-site nuclear power plant. Well, they built power. Anyway, from the dock. During a super heavy landing at the vehicle launch area, the deluge system would be reactivated and run for approximately 30 seconds. At this time, Starship landings at the VLA are not anticipated to require deluge water. Brownsville Public Utilities Board is contemplating the installation of a public water line from Brownsville to Boca Chica that will remove trucks transporting water along State Highway 4. Oh, dude, it's just like Workers Hills. Oh, gosh. I didn't know that old building was for that. Now it's got broken windows and rusting away. Which building, Sawyer? The power plants are still good. Look at those transformers. Damn. Those are step-up transformers. Yowza. The first one. Replace with small nuclear, please. That power plant's still operating, dude. Both of these power plants are still operating. Yeah, this power plant still works, dudes. Sawyer, this one's still online. I think he means the gas place. This is air liquide. This still makes LOX, guys. It just doesn't make it in the quantity that it was designed for. And you guys want to see something super cool? Take a look. There's your transformer. There's your power lines. Green propellants, baby. Green propellants, baby. SpaceX surely uses lots of LOX. Yeah, awesome. That's what I'm telling you. They built out all these facilities. And okay, let me backtrack. They built out all these facilities anticipating a high scale of launching. That never happened. But there's still launches from the Cape. So they built out these facilities to be kind of bare minimum. Over the last couple of years, they've been upgrading these facilities. You notice how SpaceX just seemingly has LOX all the time to launch 2 to 3 times a week? This plant, and then there's another one in MIMS, finally are able to be scaled to the scale that they're trying to get at. What is LOX? Liquid oxygen. Yep. Yeah, that power plant's still running, dude. Yeah, absolutely. It's absolutely still running. Man, these are really old pictures, by the way. Want to see what that looks like now? Watch. It's a little different. Yeah, it's a little different now. Is there any news on SpaceX manufacturing methane like they stated they would years ago? No, not that I know of. What does this mean? After landing and safing, the breakover fixture assembly, controlled supported drop from vertical to horizontal of Starship would commence. Where'd you find that? Oh, there you go, goalie. Yeah. Do they make the methane with solar power too? Don't know. 154 pages. What page? ¿Qué página, amigo? Rápido. Come on. Rápido. Vamos. Control F. Instead of you telling me what page to go to, you're telling me to find it myself. All right. I'll remember that next time. Hey, EJ, it's on page 24 or page 13 on the print. Oh, thanks, Helzekin. Very cool. I appreciate you. Not. What is this in regards to? Proposed action emission rates compared to 2022 PEA emission rates. During all attempts, SpaceX expects residual LOX and methane to remain on Starship during descent and landing. Unlike other launch vehicle propellants and fuels, LOX and methane are not hazardous air pollutants, and residual LCH4 and LOX would be vented into the atmosphere following the landing. After landing and safing, the breakover fixture assembly, controlled supported drop from vertical to horizontal of the Starship would commence. Because of the small scale of emissions in the context of the minimal mobile source operations required by the proposed action, air pollution emissions are not expected to have a significant impact on air quality. Horizontal, huh? They vent residual, Deadbringer. It's not in high quantities. You can vent methane, you just can't vent a lot of methane. Where else does the word breakover show up? That's the only time. Let's try horizontal. Huh. I mean, it would make sense to move starships around horizontally, guys, especially if you're going to manufacture at Boca Chica and then move them to the Cape. Manufacturing, like turning a starship, putting it on its side, putting it in a barge and shipping it to the Cape. We already know the Cape has that infrastructure, would be smart. That would make a lot of sense. Is there somewhere else with safing operations? That's the only time safing shows up, dude. Interesting. Interesting. That's interdasting. Ah. How do you support it? Through the heat shield? Unless they transport it upside down with the leeward side connecting to the supports of some kind. Why not a transporter erector, a Havix? Give me, here. No, hold on. Just shut up. Shut up for a second. Yee. Oh. Why not do something like this? Look how long the external tank is, by the way. You could do this and have a transporter just like this and have it pick up on Starship's pins. The hanging pins. That's already there. Moonji diapers. See what I'm saying? Seems fair. I'd buy it. Dude, can you imagine a transporter erector that's this, that will take Starship, put it vertical, and then the chopsticks come and pick it up? Oh my goodness. Yeah, with SLS too. Yeah, right. $75 million. The external tank? No, that's not a 1960, but or we simply ask Elon. Yeah. Look, man, all I want, dude, it's all coming. Dude, if they, I mean, moving starships horizontally around would make them way easier to transport, guys. You could move starships anywhere. Like, for instance, if you land one and recover it off the coast of Australia, moving it horizontally would be kind of preferable, don't you think? Trying to tow that across the entire Pacific when it's up like this. Not that you could get it upright like that. If it lands and belly flops like that one did, right? It's staying horizontal for a little while. Maybe SpaceX is doing some type of horizontal integration for Starship. Shuttle payload base style. Oh, please. Please do this. Please, rocket gods, please. The Starship is not, I mean, Helvish would take one of the largest hydraulic cylinders in the world. Starship is, by itself, unfueled, is not that heavy, to be honest with you. No heavier than a Falcon 9, a fully stacked Falcon 9. SpaceX has no problem turning that thing upright. How hard is it to erect a rocket, Pop? Yeah, that's a complicated thing to do. Yes. Deadbringer. Annual operation scenario: 25 Starship and booster orbital launches, 17 daytime, 8 nighttime, 25 Super Heavy booster landings, 17 daytime, 8 nighttime, 25 Starship landings, 17 daytime, 8 nighttime, 5 Super Heavy booster static fire tests, 5 daytime, 6 Starship static fire tests, 6 daytime. Interesting. You were thinking Super Heavy. Oh, Super Heavy. To do that with Super Heavy would be a little bit difficult. Yeah. Projected annual operation scenario calling for 25 launches. I'll bet you that's what they got lined up for like 2026 or 2025, Deadbringer, or something like that. Probably next year is when they'll start really scaling up, depending on how well these test flights go. You know how I know? They have to. Lunar Lander, 2026. You have to. Kind of important. And they need to figure out how to lay them on the side at some point to get them, because I don't see them building them here anytime soon. SpaceX is gonna, dude. They're, forgive me for presuming, but they're taking pages out of the space shuttle's playbook. That opens up the door for payload integration, for horizontal payload integration for Starship. So you get Starship maintenance facilities and Starship reintegration facilities for loading payload end up looking more like the orbiter processing facilities from the shuttle. And you know what? I'm okay with that. I want it. I want a Starship horizontal processing facility. That would just make me very happy. Yeah, they could fix Hubble. Yep. Definitely not the page on flying crew on the first flight. Well, we know they didn't do that, so yes. All right. Anyway, there's a couple more things I want to jump through here for space news. A couple of good things here. Let's see what we got. So this is from Rocket Lab. Rocket Lab has the Escapade satellites. These satellites right there that Rocket Lab is completed with, right? Rocket Lab completed making the Escapade satellites. Those are launching on New Glen's. That's a New Glenn launch, the Escapade mission. That's its first launch. So we are actually a lot closer to a New Glenn launch than you might think. They wouldn't make the satellites are ready to go. Escapade are the satellites that, Blue and Gold are the satellites that are going to launch in tandem on New Glenn. A real question, does Starship fit under the 401 bridge when it's up, or would it need to come in from the south? Vertical or horizontal? Vertical, it probably could do it, goalie. That's a big mission to start with. New Glenn's, dude. If New Glenn is moved around horizontally, Starship can be too. My man. Anyway, that's good stuff, man. That means a New Glenn launch is on the horizon. Quick question. How tall are the SpaceX hangar doors at KSC for the HIF? Maybe. It's not just Falcon 9. It's enough to move the Falcon 9 with its TE out. And in that regard, it's quite large. You might be able to fit a Starship in the... But even if you could fit it in there, good luck getting any payload in it. Top of Starship would basically be at the ceiling, you know? That's a good thought. Anyway, so this is Jordan Noon. Jordan Noon was the chief technical officer for Relativity Space for a little while. What is he talking about here? During today's docked hot fire test, Starliner thrusters performed at peak thrust rating values, and the helium system remained stable. Data will be reviewed and included in flight rationale for the crew flight test undocking from the space station and return to Earth. Raise the HIF roof. Havocs, I personally think that they're going to demolish that building. They're going to demolish the HIF at 39A eventually, and they're going to use the VAB for Starship. That's my EJ Crazy Charlie Day meme thought. I think they're going to get rid of it. And that's part of the reason why I think they're going to move Starship to a mobile launcher design. I think Elon wants the VAB, the VAB. I think he wants it. Think about it. How awesome would it be, and how prestigious would it be to see a Starship roll out of the VAB? And not just that, a Starship roll out of the VAB constantly. Think about it. Is there a way to land starships at sea like they do Falcon 9s? If you put a catch tower out there, Slackster, sure. I think Elon wants to build his own VAB. Remember, the VAB has 4 bays in it, dude. You can operate in one and never touch NASA's anything. The VAB has 3 cranes. No, it is 4. It has 4 cranes in it. There's 2 huge cranes that go across from high bay to high bay, and then there's actually, and then there's another one in the transfer aisle. Oh yeah, you'd never have to worry about it. And if they're moving Starship horizontal, the VAB is a really good place to be able to turn them upright. That's the only place that you could do that. Unless you wanted to just go rent another crawler crane constantly every time a Starship comes to the Cape. I'm convinced, man. I want SpaceX is going to use that VAB. They're going to use that VAB, and when that day comes, I'm going to laugh at all of you. I'm going to laugh at all of you. You called me crazy. You called me crazy. No. I assume at this point he'd just buy his own crane. You can't will it into existence because you like it. I willed launch pads into existence in the video game Wisp. You're talking to the wrong guy, man. No, it wasn't Hellfish. Somebody asked a question about it. All right. The cool factor is what I think they'll go after, Aqualex. I really do. Fully functional KSP VAB. That's right, Goatman. That's right, Goatman 2. You tell him. Would Neutron be able to launch Escapade? Yeah, I don't see why not, but Neutron doesn't fly. It's just a bunch of panels on the ground right now. To be fair, New Glenn hasn't flown either, but New Glenn is closer to being not flying out of that status sentences. Anyway, what does Jordan Noon say? He's talking, this is in regards to Starliner. This test is insufficient to demonstrate full performance of the RCS thrusters. The thruster issues manifest at high duty cycle operations or long continuous operation. Both of those are required before and during re-entry. Performance is demonstrated by a variety of factors inclusive of duty cycle and duration performance, not just thrust. Boeing has made statements that these issues manifest during heavy usage. The primary factor changing during that heavy usage is thruster components getting hotter. Most importantly, the valves that control the thruster operation. Okay. As those valves get hotter, you can get internal seal degradation and leakage. That's right. Perhaps related to their helium leak issues, perhaps not. The helium leak issue was, they said it was not part of the thrusters getting too hot phenomenon. These are pneumatically piloted valves, so helium is running to the thruster valves. You can get propellant boiling, you can get valve solenoid temperatures out of spec causing a variety of issues, etc. All could cause abnormal thruster behavior and the flight computer to disable those thrusters as has been seen in flight. Peak thrust means nothing. It's not even a throttleable thruster. Duration and duty cycle matter here to demonstrate that these thrusters will perform nominally and reliably during ISS reentry, and those can't be tested reasonably while connected to the ISS. Before I read any of the responses, does this man understand that they're also doing flight testing? They're also doing testing on the ground of full duty cycle over long duration periods of time at White Sands. Does he understand that? I'm actually asking. I'm not being a dick. Well, not yet, at least. Which isn't in space. That's okay. Yeah, Helfus, you say it's not in space because we're looking for a one-to-one analog to replicate the failure mode that they have. But how would you look for that failure mode right now? Other than doing that, I'm pretty sure that the ISS thruster firing, because we listened to the press conference, listening is important, was just one thing that they were going to do as part of their fault tree analysis. That's one thing. Now, nothing that Jordan said there was wrong. That was right. Everything there was right. But the White Sands tests are also there to check for solenoid seal degradation and also check for heating, right? Now, I get it. They're firing them down here. But, if they push the thrusters to seal degradation point down here, I mean, yeah, it's going to obviously be a little bit, they're going to be able to survive a little bit longer down here because of thermal convection, right? But see, my question back to that is, okay, so what are we going to do? Launch another one? How else are you going to replicate this problem as best as you can? What I'm trying to get at is that this is one component of the fault tree analysis tracing. What the hell are you going to do? Just let Starship thrusters go willy-nilly? Boeing said in their press release that this is for the helium leak checks. They tested the thrusters at peak thrust for helium leaks. This has nothing to do with blowing out the thrusters. That's what Steve Stitch said in the press conference. I'm super confused. Did this guy miss that? He must have missed it. I'm not saying this guy's an idiot. He's definitely not. He was the CTO of Relativity. They're not stupid. I'm wondering if he has all the information here. But anyway, let's see if he tells me too. Let's see. You guys are saying look at the comments. That was fast. Boeing added you to their list. Oh, I like this guy. I like Jordan. Jordan's all right. All right. Let's see. Peak thrust means the force value was measured to be 100% of the design thrust, where degraded thruster performance was not always at 100%. It doesn't take a throttleable thruster to have a difference in force output. That's right. Please explain how testing at peak thrust, if you can even call it that for a non-throttleable thruster, indicates health of the thruster for long duration or high duty cycle burns, where the issues have manifested. Well, which issue are we talking about here? Once again, these tests seem to be pertaining to the helium system, not the thruster blowout problem here. Am I wrong? Did I miss that? They said to test it at peak thrust rating. Peak thrust rating. Peak thrust rating also is proper nomenclature for indicating that these thrusters are rated to a certain thrust, i.e. not throttleable. I mean, they could be, but and the helium system remains stable. Steve Stitch said in the press interview the other day that this is pertaining to this test was pertaining to the helium leaks. Is this a battle of semantics? No, I think this guy's barking up the wrong tree. Rocket guy. Hi, by the way. This was to determine if any thrusters were firing at less than 100%. No, it was not. As mentioned in my post, the performance anomalies manifested after long-duration burns, high-duty cycle burns, so getting peak thrust from a test during conditions that historically have always resulted in peak thrust means nothing for what happened. Oh my goodness. He was a propulsion engineer lead at SpaceX for Merlin in early Raptor designs before he founded Relativity with Tim. He still works at Relativity as a senior advisor. Yeah, I'm confused. Once again, there's two big things, big line items with Starliner right now. And keep in mind, these are problems that you want to catch during a test flight. So I don't think this is like a mark against Boeing or anything. Every capsule is going to have teething problems, guys. It happens. Okay, it happens. DM2, SpaceX's first flight to the ISS, stayed up there for longer than intended as well. Okay, it happens. Dragon has leaked helium before. They all do. Helium's really hard to contain. With that being said, I'm not trying to run cover for Boeing. These two problems, you probably should have figured them out on the ground. One of them, helium leak, that's kind of hard to figure out on the ground. Every spacecraft leaks helium. The shuttle did, Dragon does, the Apollo CSM did. Starliner's no exception to this rule. Orion probably has helium leaks to some extent because that's just the nature of the beast. Helium will leak in the same way that a ship, like a ship that goes on water, or a boat, would have water leak into the hull somehow and wind up in the bilge. It happens. You just have to deal with it. Helium's the same way, right? So that's the one problem. They're getting helium leaks because they're not sure that the flanges are working correctly. They think the flanges are pinched on the actuator for the valves on the thruster. Okay? That's one. That's one line item that they're chasing. The other one is that they're experiencing thruster blowout. Their thrusters are being shut off by the computer because they're getting too hot. They're getting too hot, and this is what Jordan said is right. He's absolutely correct. You're getting seal degradation on your injectors here, on the NTO and MMH injectors. That's the fuel and oxidizer. You're getting seal degradation due to high temperatures, and the computer is just shutting them off rather than risking boiling hypergolic propellants and having it overpressurized, and then you have a bad day. It just shuts it off. It's just a thruster blowout. They're experiencing seal degradation because their thermal model was not accurate. They said that the motor's going to get this hot for this type of duty cycle, and their thermal models for the thrusters overheating was not accurate. It was not what they found. Now, that's a problem. Your thermal model wasn't good enough. That's a glaring oversight. I'd be curious as to what the deviation of their thermal model was, but I can tend to say that all of this comes with inexperience. It comes with inexperience. And go back to exactly what I say every time we talk about Starliner. Boeing's never made a capsule before. They've never made one before. You've never made one before. Is Boeing up to the task? Sure. The capsule in space kind of speaks to that. But also, it speaks to inexperience. Yes, Starliner does use a lot of old shuttle components, like the thrusters. But the people that figured out how to make those thrusters work and figured out how to get them to not blow out and figure out how to alleviate seal degradation were fired by NASA a long time ago. And probably Boeing by proxy. They were laid off after the shuttle program left. So that technical knowledge went out the door a long time, almost a decade ago. You have a new crop of people, new capsule, new test flight. You're going to get problems, and it's going to take a second to relearn that institutional knowledge. That's what I mean when I speak to inexperience here. The Apollo 13 CSM leaked a lot. Yeah, right? But yeah, that's what I mean. So there's two problems here. There's helium leakage problems, or the rate of helium leak when it comes to thruster actuation. And then there's the thermal problems. Once again, the thermal problems is kind of a big deal. You probably should have made sure that was good, but you ain't going to know until you go. This happens. So I'm curious to read this thread even more. When looking at this in previous flights for Starliner or for other vehicles, not all thrusters which have been seen to have performance degradation go back to 100% later. This would be a final check for that data point. And that's the survivability study. Okay. I said survivability study because that's the icon for survivability studies in the tech tree in the research tree for Hearts of Iron 4. It's called survivor's bias, but also at the same time. Survivor's bias. Jim just requoted himself. If I have to over-explain it to you, the on-orbit hot fire demonstrated that the thrusters perform nominally under conditions that they have historically nominally. This has a parallel to the survivor's bias meme. If you are focusing engineering effort on the conditions where a problem occurs, for the meme where the plane does not return home. Yeah, this diagram shows where the returning World War II era planes were hit, suggesting that the red clusters should be reinforced, exemplifies survivorship bias as only the planes that didn't crash were analyzed. Yeah, okay. Just that was for the record for everybody else. Yeah. If a plane comes back with this many freaking bullet holes in it, that's where you don't need to reinforce. Right? The planes that crashed, you got to figure out where they got shot, because clearly it wasn't in these areas, right? I mean, that's fair, but I'm not 100% sure how it pertains to survivability here. Yeah, see, here we go. As I already explained 7 comments up in this thread and a few other places and other threads in this post, the conditions where the problem occurred was already tested at White Sands. That's what I mean. It's a different test. Last time I checked, the score was helium-3 rubber 0. Why don't they just coat the polyurethane in silicon before using it as a seal? Helium will leak right past it, Jay. Polyurethane, silicon sealer, it doesn't matter. It'll go right past it. Helium is really, really freaking small. It'll permeate right through it, like water through a sponge. It's really hard to contain. Wow, this guy's going off, dude. Second only to hydrogen. Well, Rocket Guy, yeah, I always tell people that helium and hydrogen are cousins. They're basically cousins. They're basically first cousins. Oh, dude, that survivorship bias thing made me want to play Hearts of Iron. Damn it. Crap. I've been listening to the press conference, but you seem to have the answer, so tell me, was the White Sand test running at high duty cycles sufficient to degrade the thrusters as seen in flight, then a lower duty cycle sufficient to achieve a normal trajectory before the reentry burn, followed by a continuous burn and an RCS profile for the reentry burn and the reentry itself, plus some multiple in the cycle counts to consider this a requalification for the mission's needs? Okay, Rocket Guy, at this point you might be right. Dude, am I crazy? Or is this guy missing the point here? Like, am I nuts? Maybe it's just me, and I'm not trying to run cover for Boeing. If their thermal model is not if their thermal model for their thrusters duty cycle wasn't modeled correctly, that's a glaring issue. That's a big problem. Like, you got to fix that. But how the hell else are you going to fix that right now? Rocket Guy, double check me. I think he's confusing the helium qualification test, or the helium, not acceptance, the helium, testing the helium leak system with the thruster blowout, with thrust seal degradation. I think he's conflating the two. Starliner has two problems, not one. Now, they're not, and I keep calling them problems. They're not really problems. It's just stuff to learn from. They had these issues on the second uncrewed flight, didn't they? Yes, they did. They did, which tells me that their thermal model wasn't good then. This reviews the root cause of seal degradation from the increased temperatures. The debris from that seal can cause downstream flow problems, as has been seen on your test stands and in flight.
Discovery.
Doing a single thruster firing demonstrates that the flow problems do not currently exist in the other thrusters, but that does nothing to show that a damaged degraded seal will not have debris coming loose from the expected cycle on the valves for the remainder of the mission. The computer will shut them off. I'm honestly confused as to what his point is regarding the test. I don't see how this relates to survivor's bias. Yeah, I don't get that either, Rocket Guy. Yeah, I'm with you. I honestly feel like he's just getting caught off by some semantics about how Boeing described the test. This guy's really pissed off. Like, yeah. I mean, here, we'll keep reading. Maybe we'll learn something. You have zero rationale to say that can't happen because it's already happened in one thruster with fewer cycles than this total mission demands. A return flight involves a roll of the dice that additional debris coming loose will not cause sufficient number of thruster failures to impact crew safety. That is not something you can prove, being that you have zero idea of the health of the remaining NTO valve seals. And you do? There could be one cycle from fragments breaking loose, given the degradation you put them through by running the thrusters at soak-back temperatures above where they were originally tested. This testing at White Sands could have had a helpful result if the root cause was other thermal issues like propellant boiling, solenoid resistance increases, or other issues that are only present during the higher temperature environment. However, the White Sands testing highlighted an issue with permanent impact that cannot be discounted moving forward. I'll add that this also demonstrates zero context to what happened over the thrusters with transient issues. Why did only one thruster not recover from this? If the root cause was debris, what changes to cause a thruster to recover from a clogged NTO filter? This root cause appears to be valid for only one of the thrusters that did not recover, and you have a multitude of thrusters that did recover from their issues on approach. They cooled off. Rocket Guy, that's where I'm getting confused, dude. So what, like, everything that the dude's saying is kind of on point. Like, I get it. NTO is nasty stuff. It degrades things, especially at high temperatures. Like, I've been reading about it because we've been talking about Starliner so much. So what the hell are they supposed to do? Just say frick it and send them home? Like, what's your point here? That they shouldn't do any testing? I don't understand. What are you trying to say? What is sufficient testing for Starliner if you were in this scenario? Because it's easy right now to say, oh, well, they should have tested this on the ground. Yeah, no shit. I mean, I'm not trying to be a jerk here. Like, yeah, obviously, dude. And they shouldn't have launched Challenger in 1986 because it was too cold. Great, good. I don't understand, dude. Why are you getting so worked up about this? Armchair quarterbacking is much easier than being in the field. Toothless, that's what I don't understand. This guy has field experience. He was a SpaceX propulsion engineer. I'm so confused. I don't understand. I don't understand how the RCS thrusters are not tested using the flight profile during development. Now, see, that's fair. That's fair. I agree with that. The whole, like I said, the whole thing reeks of inexperience. Yeah, weather guy, yeah, I got to time myself out. No, Jay, Jordan knows what he's doing. I know. I mean, dude, that resume speaks volumes right there. So he's explaining that the testing doesn't, he's saying that the testing is insufficient to try and isolate their failure mode, CW, but what else are you going to do? Like, that's what I mean. All that stuff, dude, he's exactly right about NTO filters getting clogged, seal degradation. That's right. That's all correct. What do you do? What do you do in this scenario? That would be my question to this dude. Okay, you run Boeing. You are Mr. Boeing right now. What do you do to fix this problem? From that last spout of his, it seems like he's saying their test didn't cover enough to be able to pinpoint the issue. My question back is that what Boeing was trying to do? This is a system deployed in the field with crew. So I would think this test was to verify that they can get home and to see what systems are good, not to prove the issue was fixed. So if Boeing is claiming that this test fixed the issue, then I get his sentiment, but they're not. Yeah, sell my shares. Pretty good, man. All right, that's pretty funny. Dude, oh my god. That was good, man. Problem solved. Oh my god. That's pretty funny. Okay, all right, I'm over it. What's this next one? Dude, I'm like, this guy is just really mad. The original post says docked hot fire test, and the thrusters perform at peak thrust rating, not peak thrust test. I.e., they hot fired the thrusters and measured the thruster force output, and that measured force was the peak force that they were designed to produce. I am amazed you were able to get -3 +2 uncertainty on the thrust data, given you were measuring torque response on the ISS. Would love to see how the uncertainty analysis was that tight. Okay, all right. Just some context here. You see this guy, Jim May, that he's talking to? There's a reason why I follow Jim May. You know why I follow Jim May? Because he's an engineer on Starliner. Homie, you are arguing with someone who works on the damn thing. Homie! Bro, he's an engineer for Starliner. Dude, what are you doing? What? Look, man, you could be a genius. You could know everything about everything, right? But to insinuate that you know more about a project that somebody else is working on is a little absurd. Jim works on Starliner. He was hosting the Starliner cast when they launched. He was there. He was hosting it. I'm just putting it out there. Like, dude, I'm not gonna sit here and say that Starliner doesn't have these failure modes need to be understood, and a fault tree analysis needs to be conclusive before you even think about sending those people home, pushing Sunny home. But also at the same time, what the actual frick? Yeah, these two are very smart. They're very smart people. Very smart people. Anyway, thruster work with a 2% change, one could fail. So I'm no scientist or anything, but am I right in saying bigger things have bigger air pockets, meaning if a rocket holds more air pockets, this potentially causes oppression of inert gases? No. It's all about the pressure. It's all about your feed pressure. Yeah, I don't get it. Like, I'm not going to sit here and say that all the stuff that Jordan said was incorrect, but it wasn't. He's absolutely right about NTO seals. Like, that's... I'm just not really sure. Okay. Yep, this is a semantic exercise. I'm kind of over it. I'm kind of over it, bros. Kind of over it. Just... Best thing from Jim. I remember this thread. Yeah, I remember this thread. Yes. There's a reason NASA doesn't ask random internet user number 324's input for return readiness reviews and instead polls designated experts who understand and listen to detailed factual flight information. Allison B. Hi, I'm actually an aerospace engineer. Hope this helps. Same. Homie posted a picture of him in. I think Phil, this post was why I followed Jim. I've been following since then. I was like, that's pretty funny, dude. just absolutely roasted. Jim bringing the bants, man. That's pretty funny. Oh my goodness. Yeah, me. Picture of him smiling at the cat. Hey, you know. That's my smug face. Yeah, that's my smug face. It's my smug face. Oh, that's pretty funny, dude. Oh man. Anyway, yeah, Starliner has some failure modes, and they need to figure it out. They need to figure those failure modes out and do the fault tree analysis so they can understand it better. Anyway. All right, guys. We're coming up on 9 o'clock. That was a good... What was it? We started at 5. Yeah, we got a good 4 hours of space news there. It wasn't covered when the question was asked earlier. Hypersonic weapons just tested in Florida. Results unclear. Oh. Oh, that's kind of cool. There's also the SpaceX update, dude. Hold on. I got one more. Or I got a couple more. Hold on. SpaceX has an update here on sonic booms. What was the Rocket Lab update? Rocket Lab, the Escapade satellites for the first payloads for New Glenn, the Escapade mission, are ready to go. Everything spacey is cool. I like rocks. What kind of rocks, Jay? Igneous rocks? Sedimentary rocks? What are we talking about here? Ferrous, non-ferrous rocks? Huh? Lava tubes? What are we talking about here? I like rocks too. Probably not as much as you, though. All right, updates. Starship's sonic boom. With each flight... Jane's like, wait, what? With each flight of Starship and Super Heavy Booster, we get closer to our goal of making life multiplanetary. The most important advancement to make this happen is full and rapid reusability of the entire launch system, operating Starship like an airplane, which is fully rapidly reusable after each flight. To do this, we have designed Starship's upper stage and Super Heavy Booster to be capable of returning to the launch site. The returning vehicles will slow down from supersonic speeds, resulting in audible sonic booms in the air. Audible. That's what you call that. Okay. Resulting in audible sonic booms in the area around the return location. A sonic boom is a brief, thunder-like noise a person on the ground hears when an aircraft or another object travels faster than the speed of sound. As a fast-moving object travels through the air, it pushes the air aside and creates a wave of pressure which eventually reaches the ground. Change in air pressure associated with a sonic boom, known as overpressure, increases only a few pounds per square foot. A person could experience a similar pressure change by riding down several floors in an elevator. What makes the sonic booms audible is the quick speeds at which the pressure change occurs. Generally, the only impact in the surrounding area of the sonic boom is the brief noise. There are many variables that determine the impact of sonic booms, including the mass, shape, and size of the object traveling at speeds, along with its altitude and flight path. External factors like weather conditions can also affect the intensity of a sonic boom. The strongest effects of sonic boom's pressure change are localized to the area directly beneath the vehicle, concentrated under the rocket's flight path at the landing site. Sonic booms in spaceflight have typically only been experienced by observers on Earth when encountering vehicles designed to be reused, such as SpaceX's Falcon family of rockets. You're gonna do the shuttle like that? Come on! Or the space shuttle. I'm putting it in there. I'm putting it in there. Sonic booms in spaceflight have typically only been experienced by observers on Earth when encountering vehicles designed to be reused, such as the space shuttle or SpaceX's Falcon family of rockets. Much better. When the first stage booster of a Falcon rocket returns for landing, its size and speed generate multiple sonic booms heard on the ground as a double clap of thunder. Similar sonic booms were heard during the return and landing of NASA's space shuttle. Oh, okay, there we go. Oh, yeah. All right, cool. I'm Ron Burgundy. Sad New Shepard noises.
Discovery.
SpaceX guy told me. Skydrift, hey, thanks for the 59 months. Joe-Ho with a 58 before him. In each case, the sonic boom marks the end of just one in a series of missions for the vehicle returning from flight. Data gathered from the first Super Heavy landing burn and splashdown on Starship's fourth flight test indicates that while Super Heavy sonic booms will be more powerful than those generated by Falcon landings, it does not pose any risk to those in the surrounding areas. The strongest effects will be localized to the area immediately around the Starbase launch pad. The area is cleared well in advance of launch and has been rigorously designed to withstand the environments of launching and returning the most powerful rocket ever flown. Sonic booms announce the return of rockets and spacecraft built to be reused. With Starship, they'll signal the arrival of a rapidly reusable future in spaceflight to travel to the Earth, the Moon, to travel to Earth orbit, the Moon and Mars, and beyond, in infinity. It's going to be incredibly loud, isn't it? Also, when done reading, watch the video above the post.
I know a lot of people will be excited when they hear the sonic boom.
And these are going to provide quite a show because you're going to hear the sonic booms.
Booster landing deployed.
That sonic boom was great for us.
That thunderclap broke the sound barrier.
Side booster separation confirmed.
Dude, this video's got me fired up, man.
Here in the room.
Booster landing confirmed.
Dude, we're getting fired up. Oh gosh. Okay. Can I watch it again? I want to watch it again. Shut up. Also, stubby nozzle can burn in hell.
I know a lot of people will be excited when they hear the sonic boom.
And these are going to provide quite a show because you're going to hear the sonic booms.
Booster landing deployed.
boom is great for us.
That thunderclap broke the sound barrier.
Side booster separation confirmed.
Just heard the two sonic booms here in the room.
Booster landing confirmed.
Oh, that's so good. Oh, that's so good. I love it. Also, yes, Nuglins. I saw it. There's a Nuglins. There's a Nuglins sitting back there. Oh, yeah.
Booster landing confirmed.
It's freaking kick-ass, man. Oh, that's so good. All right. Whew. I wonder why there's a double shock on the Falcon. It's the bottom of the vehicle and the grid fins. And there's actually a slight audible third boom. So it's ba-ba-boom, ba-ba-boom. So it's kind of the lead. So the engines, and then the landing legs, right? And then the grid fins. You kind of hear three. Yep. And it's going way faster than a fighter jet, man. That Falcon 9 first stage goes way faster. Yeah, I got you, 619. I was reading your mind, dude. Oh, man, that was freaking sweet. That was sweet. You know what? We're gonna repost that. This video makes me want to scream out. Shake and bake randomly. Shake and bake! Shake and bake. Not sure why. There we go. Shake and bake. Shake and bake. Shake and bake. Post. Oh, what was that? Did that just blow your mind? That just happened. Shake and bake. What is that, a catchphrase, or is that epilepsy? Shake and bake. For KSP, you should see if you can run a Starship build to build out space infrastructure. See if it is as rapid as they claim. Joking, but not joking. Oh. Oh. Why don't you just say that you like really thin pancakes? You can just say that. Look, man, I just want to tell you, I had a whole mess of crepes this morning. I had a whole mess of crepes. They're like pancakes. They're like really thin pancakes, maybe even better. I do not want to break your arm, Monsieur Bobby, but I am a man of my word. Elon Musk post. Space Brew, you're going to have to link the exact post, because me going and looking through Elon's posts for the might...
Discovery, go at throttle up.
Probably not a good idea. Frank it, Pepe Le Pew. All right, cool, you linked it. I see it. I can see the link, dude. We good. Oh, dude, he retweeted Urkex. That's awesome. Oh, nice, that's how you saw a Starlink train. Dude, I'm telling you, when this happens, I will poop a squirrel. Like, I don't know what my brain's just gonna be like, go straight like chimpanzee mode. I'll just be like, The squirrels are. I couldn't think of another substitute for brick, man. I woke up this morning and I pooped a squirrel. I mean it, literally. Trouble is, the damn thing's still alive. Oh, I'm sorry, chap. I think I ate your chocolate squirrel. Grilani, that's most likely what's going to happen. Like, sorry, it's growling at me, so I gotta growl back at it. Like, I'm... Why? You know? I believe you have my chocolate squirrel. Oh, gosh. Second place is the first loser, Bradley. If you ain't first, you're last. All right? If you ain't first, you're last. Boosters and Ignignot. Is it weird if I want a hypergolic starship? Yes. Yeah, that is a little strange. EJ wouldn't try to assert dominance over a rocket, would he? No, never do that. Okay. All right, hold on. Let's see. What's this next article? Oh, and this picture from earlier. This thing goes Mach 2.5. Mach 2.5 while flying 15 feet above the surface. What? We're proud to support the U.S. Navy with the recent GQM-163A Coyote target launch at the Wallops Flight Facility to test anti-ship cruise missile defenses and provide advanced training scenarios for our nation's defenders. What the frick, dude? What? That thing goes 1,500 miles an hour, 15 feet off the ground. 1,500 miles an hour, 15 feet off the ground. Okay. That's actually awesome. I know it's a missile, but bro, if a war goes hot, that thing's going right up someone's rudder, tailpipe. You know what I mean? No outrunning that. Pulling 10G maneuver? What the frick is this thing? Dude, what the actual frick? Whoa. Right up the sphincter, yes. Wow. That's really cool, actually. Maneuvers above 10G acceleration. Damn, that's cool. It looks to be a two-stage. My guess is that the kick right here, the first part, is just designed to get it up to speed to make whatever this thing does work. That's... yeah. Let me guess, those are $10 million a pop. Yeah, they may be, Jim, but that's $10 million to take out a $1 billion ship. Pretty good trade-off. That's an air-breathing solid rocket engine. Well, I made Dart fly today, so there. Or something. Mr. Dick! Nick, anything good? It's not even an anti-ship weapon. It's a dud pretending to be a cruise missile so we can test things that can shoot down cruise missiles. But does it have a Hemi in it? That's what I want to know. Yeah, Alexander, have a Hemi in it. That's the important information we need to know. If it does not have a Hemi in it, then I am not concerned. Seriously though, that thing is nuts.
Discovery, go at throttle up.
And they can launch up to 4 of them at the same time from the launch stand. I think it's pretty cool, man. I'm not gonna lie. This thing's pretty neat. Now, what's this hypersonic test that we were testing over here? Hypersonic weapon just tested in Florida. Results unclear. Ooh, that's cool, man. Dude, look at this thing. Oh, I don't hate that. I'm talking about the Hemet. The trailer is cool too, but the Hemet is kind of where I'm at here. Dude, look at that transporter erector and launcher. Just built into a freaking lowboy. That's pretty cool, man. I think this one is a Lockheed project. Yes. Ultimate camping vehicle. Dude, I want the Hemet. Is that bad? Like, this part's cool. Don't get me wrong. That part's cool, but I want one of those. I can't do anything with this. I can do stuff with this. You know what I mean? Can you imagine road tripping in that thing? Yeah? Yeah? Because why not? Why not do a cross-country road trip in a vehicle that can tow a bajillion freaking pounds behind it and is also NBC compliant? Nuclear, biological, chemical. Geek's like, yes, I can. Gallons per mile. Bro, I already... You know, I know somebody's going to be like, well, AJ, what about the fuel efficiency? Bro, did you see what we road tripped in last time? Did you see that? That wasn't, you know, a model for fuel efficiency, okay? But it can tow like a mother trucker. Get it? Mother trucker? Yeah. Your mom tows things. That's what I'm trying to say. I want Coco. I gotta go poopy. Actual cross country. Ignore the roads. Yeah, who needs roads? Where we're going, we don't need roads. Your mom's toes? What? Hell yeah, toes. Good afternoon. Welcome to Pop Coffee. Can I help you? I used to drive those things fully loaded at 80 miles an hour. See? It can be done. Hey, she's a nice lady. Any more pictures? Yeah, it's still cool. It's built like a steakhouse, but handles like a bistro. That thing is actually really freaking cool. The trailer I'm talking about. Like, if you think about what this is, it's a trailer rocket launcher with a fifth wheel. It's like, it's practically a gooseneck. Actually, this is a retractable gooseneck, so you can, it's kind of works like a lowboy almost, from what I can tell. It's pretty rad. I kind of want one. But, you know, I don't need this part. I don't need that. Like, you can have that part. I just want the trailer. Fish, do you think if I just call up Uncle Sam and be like, yo, can I have the trailer? They'll be like, you can't have the trailer to our super classified missile. I'll be like, yo, you could take the launcher stuff off. I just want the trailer. They're like, oh, government auctions, go. Enough to conjure up a 100-foot marshmallow man, blow the top 3 stories off an uptown high-rise, and get sued by every city, state, and county agency in New York? Gosh dang yuppie larva. You know, Hippo, my dad said you're full of crap. You're full of crap. It's a modified lowboy trailer. Yeah, but it's modified in a cool way that I want. It's modified in a cool way that I like with the rocket launcher. Song. Nice. Do you not know what this is? It is the coyote. You are like the buzzing of flies to it. GoFundMe? Oh, crap. We're at that phase in the stream where we bust out market. Oh. AV92 Detroit. Oh, I want it. Oh, it's got the crane on the back. I really want it. But I don't have 36 grand. Damn it. Oh, that's so cool. I don't need it. I don't need it. I definitely don't need it. I need it. Flip some cars quick. I don't want to. Quick, well, Brimo's out of the country. Quick, give me 36 grand then. I'll go drive to that guy's house right now. Take a loan, like in Workers and Resources. No, that's not a good idea. It's registered. It is registered as an antique. Will assist in loading if you don't want to drive it home. What the hell are you gonna load? All right, whatever. You need a CDL to drive this? I know a guy. It's fine. It's fine. It's not a good idea. It's a great idea. Right. You know what? God dang it, Chad. You drive a hard bargain. How cool would that be to own a Hemet? I'm not saying, like, if I had that crazy, like, YouTube or TikTok or whatever money, like what all the kids do, that I wouldn't just be doing that. I'd have a warehouse just full of tanks. Like, they could be demilled, whatever. Just want to drive the tank around. Like, it would just be trucks. And it would look like a child's sandbox. That's what I'm trying to say. But the trucks would be real. Antique equals no inspections. Turbo it. I know it's already turbo. Turbo it again. See, Kraken's like, 100 bits, I helped! I mean, that is what Jay Leno does with this money. I would just have Hemets. And, like, Humvees and stuff. Like, people would be like, oh, military got... No, I just want Humvees. I think they're cool. Buy a Hemet wrecker and go to work. Well, Fish, you know... Here, you know what? All right, as long as we're talking about, you know, shopping around for the military vehicle that best suits my needs, I'm just going to come in here and...
Oh, this is space. I'm in space.
Pokey gifted a sub to Yuri. Thank you. Thank you. I'm just going to sit here and tell you about the tank that best suits my needs. All right? That tank is our Lord and Savior, the M88. Okay? Look at it. It's amazing. It's perfect in every way, shape, and form. Yeah, kind of like Grindhard Klavic. Yeah, something like that. Heavy D bought a Blackhawk. That's all? You just bought a Blackhawk? Bro, I'd buy these. Look at that thing. Look at it. Fish, you know why this is the best tank? Because, you know, everybody else wants a, you know, I want an Abrams. Oh, I want a Chieftain. I want a Challenger. I gotta go poopy. Oh, sorry. You know why it's the best tank? Because no one's expecting you to take a tank into battle with a crane on it. Okay? They're going to expect a gun. All right? No. We don't have guns. We have a crane. Okay? Still funny. Still funny. Yeah, see? No one's expecting you to bring a crane into battle. They're going to be like, what is that guy doing? And then I just pick your tank up and throw it somewhere, okay? Nobody is expecting an M88. That's my tank? No. That recovers tanks. A tank can't recover other tanks, Salamander? What are you, racist? Can a tank swap an engine from another tank? I think not. You're being tankist. Me, I like racing. It's a nice helicopter engine. Wait, they actually did that? Dude, that's what I mean. No one's gonna be expecting your tank with a crane on it. That's all I'm saying. Yeah, that's the pack. Yeah, the Abrams is a modular design. The engine and the gearbox, you could just pull it right out in one shot. I know, because of the way that is. It's your shop A-frame. That's what I'm saying, Aqualex. This thing could lift up Bluefus, no problem. An M88, the M88 could lift up Bluefus. It could lift up Tough. It could lift up Freb. It'd probably lift them all up at the same time. For real. This thing can lift an Abrams tank up. It's fine. Give me an M1074 instead. This is cool, but it looks like you're moving around a wedge of cheese. Two of them can suspend a D7. Don't ask how I know. That is a pretty heavy bulldozer. I mean, that's cool. Don't get me wrong. But also, you could lift a bridge up with the M88. I've thought about this, dude. I've thought about this. I'm a surveyor, I like easy river crossings. But could you not make a bridge with your A-frame tank? The state tank of Wisconsin. Oh, yeah, it's just moving around a big wheel of cheese there. Oh, yeah, look at that nice big wheel of cheese. Oh, that's great. We should take that up to the Packers. It'll be great. No. No. Okay. POV, you chose the Bridgelang tank over the M88. Actually, this picture low-key gives me the heebie-jeebies. I really do not like staring down the bore of a 120mm smoothbore cannon. Yep. Don't like that. Don't like that at all. That was not cool. Yep. Yeah, I don't like that. Anyway, that's a sight I never want to see in person. Yeah. I don't like that. I was getting the heebie-jeebies from that picture. I do not like. Nope. It's like staring down an A10. I've had that happen to me, Blue Flare, and I was just. Ugh. Anyway, guys, that's gonna do it for Space News. I'm just running a little bit of a shorter schedule here this week, just because I got the boy with me. Look at this boy. Look at this boy. Look at that boy. He's a good boy. Space News ever? Hell yeah. Hey, Titan. Come here, buddy. Come here. You want something to eat? You hungry? Come here. Want some food? Come on. What about a Sheridan? I mean, if you want to drop out of the back of a plane, that's kind of cool. Hey, come here, pal. Yes. You like the food, don't you? You're a good boy. Have you seen F-18s participating in RIMPAC with SM-6s from a DDG slung on the pylons? You know those SM-6s, the one they used in the ASAT test? No, but that's kind of cool. One Titan Twitch emote. I'm working on it. All right, Bugzer. Let's go. Let's go inside. Yeah, you got to get your stretchy. Stretch. Okay. All right. Yeah, I do have to upload it. I'll do that. We'll do that tomorrow. Anyway, that's going to do it for me, guys. I hope you guys enjoyed Space News, and I hope you guys enjoyed playing Kerbal. I'm going to try my best to do more Kerbal this week. My boy. Yeah, I kind of just want to go back to my regular schedule with, not regular schedule, the schedule that we had a little while back. Minus the third segment, minus after hours for now. So we'll do Kerbal and then Space News pretty much every day this week. So that's what we're going to do. In the meantime, let's see who we can raid. Anybody else around? Actually, it's kind of slim pickings tonight. Hey, Stellar, you catching me on the tail end? Here, let's raid my buddy Terra. It's somebody that take good care of you guys. Terra's a good dude. He's playing some Minecraft right now. Playing hardcore vanilla. Never mind. See ya. All right, Stellar. Hey, I'll see you tomorrow.
This is how
buddy,
all
okay?
the job blocks are going to look in each floor. Not that one extra, but
Let's go raid Taradra, and I will see you guys all tomorrow at noontime.
That's really cool.
There is the SF-51 mission.
Wait, the reason why that one is there is because there's 37
tomorrow.
enchantments that I want. We got to find a place to put him for the zombie to still travel.
Probably can't
but the
make
zombie
that
can
one.
still travel,
We'll watch it
and there's
on
still
a replay for
job
Space News
block all the way
tomorrow.
around.
Get your space
It's gonna look
topics
pretty
ready.
badass when it's all said and
Get
done.
ready to ask me questions. We're getting back into the.
I'm excited for it.
We're going full frontal back into space. That was a very poor choice of words. We're going to get back into doing more space stuff. But I also will sprinkle some more.
Oh, I should have checked the iron farm when I went by.
I'll see you guys tomorrow. Thank you very much. Have a
we
good
should
night.
go check that.
And thank you over on the YouTube end of things too. Appreciate it, guys. I'll see you tomorrow.
Oh, we're being raided.
Yeah, that was a great choice of words.
How
on
you
my
doing,
part.
Art Yon?
Great choice of words. Yeah, that's great. It's a great choice of words. Lovely. Go raid Taradra. I'll see you guys.